There is a place in the middle of the Atlantic Ocean where the water is so deep and the surface so far from any coast that for most of recorded human history nothing happened there. No battles, no crossings of significance, just water, wind, and the slow turning of weather systems that nobody on land would ever see. It is a place the ocean keeps to itself. And yet, somewhere beneath that surface, in the years between 1941 and 1943, some of the most consequential logistics operations in the history of naval warfare were taking place in total secrecy, in total darkness, in conditions that no sailor who lived through them ever fully described to their satisfaction. 2 submarines would rise to the surface in that empty middle distance. Hoses would be passed across heaving water, fuel would flow, torpedoes would be lifted by hand from one hull to another. Fresh bread, baked in the belly of one boat, would be passed across in canvas bags to men who had been eating tinned rations for weeks. And then, without ceremony, both vessels would slip back beneath the surface and disappear in opposite directions, one back toward the enemy, one to wait for the next appointment in the dark. Nobody on shore saw it happen. No newsreel camera caught it. Very few people in the Allied world even knew it was possible. And for a period of roughly 2 years, this invisible supply chain, this secret fleet operating beneath the Atlantic, was one of the primary reasons that German submarines could reach places they had no business reaching, and sink ships that, by every calculation of range and fuel and endurance, they should never have been able to touch. This is the story of the Milch Cow, the milk cows, 10 submarines that never fired a torpedo in anger, that existed solely to feed the animals that did. It is not a story that has been told nearly as often as it deserves. The U-boat war has its celebrated chapters, the wolf packs, the convoy battles, the aces with their medals and their kill counts, and the crews who fought those battles have been memorialized in film, in literature, in museums along the German coast. But the men who served on the Type 14 supply boats occupy a different kind of silence. They did not sink ships. They did not earn the decorations that came with confirmed tonnage. They surfaced in the middle of the ocean and held still, perhaps the most dangerous thing a submarine could do in wartime, and they handed other men the means to fight. And then, one by one, they were hunted down and destroyed, until the fleet that had never fired a shot had been erased almost entirely from the Atlantic, and with it, a significant piece of Germany's strategic reach. Understanding what the milk cows were requires understanding a problem that the Kriegsmarine faced from almost the first day of the war, a problem so fundamental and so mathematical that no amount of courage or tactical brilliance could solve it without an engineering answer. A submarine running on diesel fuel can only carry so much of it. Every kilometer traveled on the surface, every hour spent running at depth, every day spent transiting from a French port to a hunting ground off the American coast, all of it costs fuel. And when the fuel runs low, the boat must turn around. Not because the enemy has driven it away, not because the crew has failed, simply because the arithmetic of distance demands it. The ocean is very large, and submarines, even by the standards of 1941, are very small. Admiral Karl Dönitz understood this problem in precise terms. He had built his entire strategic vision around a single idea, that if his submarines could sink Allied merchant shipping faster than Allied industry could replace it, Britain would be strangled into defeat. The logic was compelling, the mathematics were, on paper, achievable, but only if his boats could spend enough time in their hunting grounds to make those numbers work. And the numbers kept coming up short, not because the boats were poorly designed or the crews poorly trained, but because too much of every patrol was consumed by the journey there and the journey back. Effective fighting days were a fraction of total patrol days. The ocean was eating his strategy alive, one transit at a time. The milk cow was his answer to that problem. A submarine redesigned from the hull inward, stripped of its offensive capacity and refitted as a floating depot, fuel in tanks that took up most of the pressure hull, torpedoes racked in purpose-built storage, food enough for weeks of distribution, a small medical bay for the wounded, spare parts for every system that might fail in the deep Atlantic. A boat that could sail out to the mid-ocean, take up a position, and wait for the combat submarines to come to it, rather than forcing those combat submarines to make the long journey home. In theory, it was elegant. In practice, at its peak, it was extraordinary. U-boats that should have turned for home weeks earlier instead rendezvoused with a milk cow somewhere in the empty Atlantic and came away replenished. Fuel tanks full, torpedo racks restocked, crew mail delivered, wounded crewmen transferred for treatment, fresh bread in hand, and turned back toward the hunting grounds for another stretch of days that the enemy's analysts had not accounted for. The patrol ranges that Allied intelligence thought they understood became, without warning, wrong. Ships were being sunk in places no submarine should have been able to reach. The calculations that were supposed to define the safe perimeters of the war at sea simply stopped working, and for a time, nobody on the Allied side knew precisely why. That period, from the first operational deployments of the milk cows through to their systematic destruction by Allied hunter-killer groups, is the arc this documentary will follow. It is a story about logistics as strategy, about the way that supply and endurance can be just as decisive as firepower, and about what happens when an intelligence service learns to see an invisible system clearly enough to take it apart, piece by piece. It is also a human story. The men aboard the milk cows were not heroes in the conventional sense that wartime culture understood heroism. They did not charge the enemy. They did not rack up victories that could be tallied. They sat still in dangerous water and did mechanical work, pumping fuel, passing stores, tending the wounded. And they knew, with increasing certainty as the war progressed, that they were becoming the primary target of the most capable anti-submarine force the world had ever assembled. They could not dive fast enough to avoid every danger. They could not fight back against the aircraft that found them. They could only do their work and hope that the rendezvous was clean and the sky stayed empty. Most of them, eventually, ran out of hope. If you are settling in for the night, this is the kind of story that rewards patience, the kind that moves slowly through difficult material, that takes the long view of events that happened 80 years ago in waters that most of us will never see, and that asks you to hold in your mind the image of two submarines meeting in secret on an empty ocean, one of them full of everything the other needs to stay alive. There is something in that image that feels important, even now. A transaction conducted in darkness, far from any shore, in service of a war that would be decided by mathematics and intelligence and endurance, as much as by any single act of courage or violence. We will spend time down in those boats. We will follow the men who built the concept, the men who sailed it, the men who hunted it, and the men who finally broke it. We will trace what the milk cows made possible and what their destruction made inevitable. If you have not already, settle in. If this is the kind of history that draws you, and if you are here, there is a reasonable chance that it is. Consider staying with us through every chapter, subscribe, and let the Atlantic close over us. The water is very deep. The story goes all the way down. The North Atlantic in 1941 was a cold and merciless place. Winds that had gathered strength across thousands of kilometers of open ocean arrived without warning, throwing grey walls of water against anything afloat. Convoys of merchant ships, low, heavy, slow, pushed westward and eastward through seas that seemed designed to kill them before any enemy could. And somewhere beneath those same waters, or threading along the surface in the dark hours between midnight and dawn, were the grey wolves. German U-boats, long and cylindrical, and smelling permanently of oil and unwashed men, hunting the shipping lanes with a patience that bordered on predatory stillness. They were, in the early years of the war, among the most feared weapons in any nation's arsenal. But they had a problem that did not announce itself in battle reports or casualty figures, but in something far more mundane and far more corrosive. They were hungry. Not the crews, though the food was never extraordinary, but the boats themselves, hungry for fuel, hungry for torpedoes, hungry for the simple mechanical sustenance that kept a submarine alive and dangerous. And that hunger, quiet and structural and easy to overlook, was slowly eating the heart out of Germany's campaign to strangle Britain at sea. To understand the scale of the problem, you have to understand the geography of the war. The U-boats that hunted Allied shipping were based primarily along the French Atlantic coast, at Lorient, Brest, Saint-Nazaire, and La Pallice, ports seized during the fall of France in 1940 and quickly converted into fortress bases with reinforced concrete pens designed to withstand aerial bombardment. From those bases, a U-boat departing on patrol faced a transit of many hundreds of kilometers before it even reached the hunting grounds of the mid-Atlantic. The journey out burned fuel. The journey back burned more. A standard combat submarine of the period, depending on its type and the sea state, could only carry so many tons of diesel, enough for a finite number of days at sea, a finite number of hours at operational speed. Every day spent getting to the hunting ground was a day subtracted from the time that could be spent actually hunting, and every day spent returning to base was another. The math was unforgiving, and the chart made it brutally visible. Far too much of any given patrol was spent in transit, and far too little of it was spent doing what the boats had been built to do. Admiral Karl Dönitz understood this better than anyone. He was a compact, precise man, and he thought in numbers the way a musician thinks in intervals, instinctively, constantly, with a kind of driven clarity that his subordinates found both inspiring and exhausting. Dönitz had served in submarines during the First World War, had been captured when his boat was lost, and had come away from that experience with a conviction that submarine warfare was the decisive instrument of naval power, provided it was used correctly and in sufficient mass. He believed, with a certainty that shaped every decision he made, that Germany could win the war at sea not by engaging the Royal Navy in fleet battles, but by sinking Allied merchant shipping faster than it could be replaced. The logic was cold and arithmetic. Britain imported the vast majority of its food, fuel, and raw materials by sea. Cut those supply lines deeply enough and consistently enough, and the island would simply run out of the things it needed to keep fighting. He called it the tonnage war, and to win it, he needed his submarines at sea, on the hunting grounds, for as long as possible. His preferred method for deploying those submarines was the wolf pack, groups of boats coordinated from shore headquarters, spread across known convoy routes, guided by radio intelligence toward targets, and then triggered to attack simultaneously from multiple bearings. The concept was sound and, in the right conditions, devastatingly effective. A convoy that might fend off one attacker could be overwhelmed when 3 or 4 or 6 boats pressed in from different directions during the same dark hours. But the wolf pack required numbers. Enough boats had to be at sea and in position at the same time to make the coordinated attack work. And that, again, was where the arithmetic turned cruel. Because for every boat that was on station, in the mid-Atlantic hunting ground, there were other boats transiting toward it, or transiting away from it. There were boats in port being resupplied, repaired, or having their crews rested. The ratio of boats at sea to boats actually fighting was, in Dönitz's estimation, deeply unsatisfactory. He pushed hard to correct it, arguing in memorandum after memorandum to the German Naval High Command that the U-boat fleet needed to be expanded dramatically. He was right. But expansion took time, and time was something the tonnage war did not afford in generous quantities. The operational reports that crossed Dönitz's desk in the months of 1941 carried a pattern that he found increasingly difficult to accept. Boats were returning from patrol, having used only a fraction of their torpedo loads. They were coming home not because they had run out of targets, or because they had been driven off by escorts, but because they had run out of fuel. A submarine that still had 4 or 5 torpedoes in its tubes but empty diesel tanks was a weapon that had been wasted, brought home prematurely by a logistical limitation that had nothing to do with enemy action. The crew came back, the The boat went into the pen for resupply. 2 or 3 weeks passed before it was ready to go out again, and all the while ships that could have been sunk kept crossing the Atlantic unmolested. Dönitz tallied these losses not in tonnage sunk, but in tonnage that should have been sunk and wasn't, and the figure that emerged from that calculation kept him awake in ways that the enemy's countermeasures did not. Food was a secondary constraint, but a real one. Fresh provisions aboard a U-boat were exhausted within the first few weeks at sea. After that, crews subsisted on tinned and preserved goods, adequate for survival but corrosive to morale, over the long haul of a patrol that already asked extraordinary things of ordinary men. Beyond food, there were torpedoes, heavy, complex weapons that had to be loaded and handled with care, that were expended in combat and could not be replaced at sea. A boat that fired off its forward tubes early in a patrol and had no remaining capacity to engage targets was a boat effectively neutralized. And then there were the mechanical realities of operating complex machinery in salt water at depth, the equipment failures, the gasket replacements, the pump repairs, the small and constant maintenance demands of a submarine that had been designed to operate at its limit. Without spare parts, and the skilled hands to fit them, a mechanical problem that should have taken hours to fix could end a patrol entirely. What Dönitz began to envision, slowly and then with gathering intensity, was a way to address all of these constraints simultaneously, not by building more combat boats, though he wanted those too, but by changing the fundamental relationship between his submarines and the ocean they operated in. The idea was not entirely new. Surface ships had been refueled at sea for decades, and the German Navy had used surface supply ships, known as Milch in the civilian dairy context, though the naval application was only beginning to take on that name, to extend the range of surface raiders earlier in the war. But submarines were different. They could not just pull alongside a tanker in contested waters. They were vulnerable on the surface, slow and low in the water, unable to defend themselves against air attack, while they sat still long enough to take on fuel through a hose. The engineering of underwater or close surface transfer was an entirely different problem from anything attempted before. Yet Dönitz kept returning to the arithmetic. If a submarine could be resupplied at sea, fuel topped up, torpedoes transferred, fresh food loaded, sick men treated, it could remain on station for weeks longer than its design range permitted. The transit time that ate so many productive days from every patrol could be eliminated or drastically reduced. A boat that currently spent 14 days getting to the hunting ground and 14 days getting back, leaving perhaps 3 weeks of actual operations in the middle, could instead spend most of its time on station if a floating supply depot met it somewhere in the mid-ocean. The effect on the tonnage war would be multiplicative, not merely additive. Each boat would effectively become 2 boats in terms of fighting days delivered per patrol, and Dönitz's entire strategic philosophy rested on the proposition that more fighting days meant more sinkings meant faster attrition, and faster attrition meant a Britain that could not hold on. The year 1941 was not yet a year of German desperation. The U-boats were still inflicting serious losses. The Allied convoy system was straining under the weight of attacks that came from multiple directions and at unpredictable intervals. But Dönitz, who read the underlying numbers rather than the headlines, could see that the trajectory was not as favorable as it appeared. The Americans were not yet formally in the war, but their navy was escorting convoys partway across the Atlantic, and their shipyards were beginning to produce replacements for tonnage lost. The window in which Germany's submarine force held a genuine strategic advantage was not infinite. The boats needed to be used at maximum efficiency for every day of that window, and the current system, with its vast expenditure of time and fuel on transits that produced nothing, was failing to achieve that efficiency. There is something almost administrative about the way a strategic turning point sometimes announces itself, not as a battle or a breakthrough, but as a question written in the margin of a report. Dönitz, working through his operational analysis in the later months of 1941, kept arriving at the same limiting factor. His boats were capable of far more than they were delivering, and the gap between capability and delivery was almost entirely explained by logistics: fuel, torpedoes, food, spare parts. The four hungers of the Grey Wolves, and all of them theoretically solvable if you were willing to think about the ocean differently, not as a barrier between the boats and their targets, but as an operating environment that could be made to sustain them indefinitely, or close enough to indefinitely that the distinction ceased to matter operationally. And so the question formed: not yet a plan, not yet a procurement request, or a design brief, or an order to a shipyard, just a question, quietly disruptive in the way that the most consequential questions always are. What if the submarines never had to come home? What if the ocean itself could be made into their base, their fuel depot, their armory, their hospital, everything a port could offer, but carried to them in another submarine, waiting in a prearranged square of grey Atlantic water? What if the logistics of the tonnage war could be stretched to match its ambition? The Grey Wolves were hungry. Dönitz had begun to think about feeding them in a way that no naval commander had seriously attempted before, and the answer he was reaching toward would extend the Battle of the Atlantic's most dangerous phase across oceans that had never expected to see a German periscope. Karl Dönitz did not think like a sailor. He thought like an accountant, not in the cold, bloodless sense of a man shuffling ledger columns, but in the precise, relentless sense of a man who understood that wars are won and lost in arithmetic long before they are won and lost in blood. From the moment he assumed command of Germany's submarine arm in the mid-1930s, he had been running calculations, obsessive, meticulous, sometimes brutally honest calculations, about what his boats could do, what they were actually doing, and the widening gulf between those two numbers. By 1941, that gulf had become impossible to ignore, and Dönitz had begun to pursue it the way a good accountant pursues a discrepancy, with total, consuming attention. The philosophy he had built his entire strategic vision around was simple enough to state in a sentence, and devastating enough in its implications to reshape an ocean. If German submarines could sink Allied merchant shipping faster than British shipyards and American yards could replace it, then Britain, an island nation dependent on imported food, fuel, and raw materials for its survival, would eventually be strangled into surrender. The Royal Navy could not be everywhere at once. Merchant convoys could not always be protected. Every ton of cargo resting on the ocean floor was a ton that would never reach a British factory, never feed a British family, never fuel a British aircraft. Accumulate enough of those sunken tons, and the arithmetic of national survival would turn against the Allies entirely. Dönitz called it the Tonnage War, Tonnagerkrieg, and he believed in it with the conviction of a man who had done the numbers himself and found them irrefutable. The numbers, however, required submarines. Not submarines in theory, submarines in place, on station, in the operational zones where shipping lanes converged and targets were plentiful. And here, in the gap between the concept and the reality, was where the arithmetic began to betray him. A Type VI U-boat departing a French Atlantic base on the Biscay coast had to travel a significant distance outbound before it reached the hunting grounds of the North Atlantic. The same distance waited for it on the return passage. Days spent crossing open water in transit were days when no Allied merchant vessel could be sunk. The fuel burned on the outbound leg was fuel not available for maneuvering, chasing, or evading once the boat arrived at its operational area. The torpedoes aboard were fixed in number. Once they were spent, the boat had to come home regardless of how many targets remained in its sights. Food, fresh water, the physical endurance of the crew, all of these imposed their own hard ceilings on how long a boat could remain effective before it became a liability rather than an asset. Dönitz laid this out in briefings to the Naval High Command in Berlin with the patience of a man who knew the figures would shock and who wanted the shock to land cleanly. He could tell them how many days a standard patrol lasted from departure to return. He could subtract the transit days, the time spent traveling to and from the operational zone, and present the residual, the number of days a boat was actually in a position to find and attack enemy shipping. That number was consistently, almost insultingly small, compared to the total patrol duration. A boat might be at sea for several weeks, but its effective fighting time might amount to only a fraction of that. Days, not weeks, of genuine offensive capacity. The rest was transit, consumption, and the slow burning of potential against the empty Atlantic. The tonnage war mathematics demanded a solution to this ratio. Dönitz's entire Wolfpack doctrine, the tactic of gathering multiple submarines and directing them as coordinated groups against a single convoy, was one answer. Instead of spreading boats thinly across a wide area, where any individual boat might miss the traffic entirely, Wolfpacks concentrated submarines against known convoy routes, forcing the escorts to split their attention while the attackers pressed in from multiple angles. The tactic worked. In the right circumstances, against inadequately protected convoys, it worked spectacularly. But it did not solve the underlying problem of patrol duration. A boat that had exhausted its torpedoes or its fuel had to leave the group and head for home, weakening the pack at precisely the moment when persistence might mean the difference between a partial success and a total one. The mathematics of concentration kept running into the mathematics of endurance, and endurance kept winning. Inside U-boat Command Headquarters, which had relocated from Lorient to a purpose-built facility as the campaign scaled, Dönitz's staff officers were working through the same calculations from different angles. His operations staff were practical men, experienced submariners, who had spent their own time at sea and understood the fuel logs and the torpedo tallies, not as abstract figures, but as the lived texture of a patrol. Among them, conversations had begun that went beyond the tactical, beyond how to route boats and schedule Wolfpack attacks, into something more fundamental. The question being asked, quietly at first and then with increasing urgency, was whether the transit problem was a fixed constraint or an engineering problem. Fixed constraints had to be accepted and worked around. Engineering problems could potentially be solved. The framing of that question changed everything. If the transit distance was a fixed constraint, if the laws of physics simply imposed a hard ceiling on how far a submarine could travel and still have fuel left to fight, then Dönitz's campaign would always be fighting against its own geometry. But if the fuel limitation could be addressed externally, if a boat at sea could be topped up, replenished, sent back into the fight without ever returning to port, then the mathematics of the tonnage war shifted in Germany's favor. Every torpedo reloaded at sea was a torpedo that did not require a boat to make the long passage home and back. Every extra week of patrol extracted from a crew that had been fed, rested, and resupplied mid-ocean was a week of additional pressure on Allied shipping lanes. The effective fighting days would multiply, the transit days would contract. The gap between what U-boats could theoretically achieve and what they were actually delivering would narrow, perhaps dramatically. Dönitz's staff began running these figures formally in 1941, constructing comparative analyses that projected patrol outcomes against two scenarios: existing operations and a hypothetical model in which mid-ocean resupply was available. The projected gains were not marginal. Boats that currently spent a significant portion of their patrol time simply moving through unproductive water could, with reliable resupply, extend their time in productive zones considerably. Multiplied across the entire operational U-boat fleet, the cumulative effect on tonnage sunk was potentially transformative. The analysis was presented to Dönitz with the careful language of staff work, cautious projections, caveated assumptions, but the conclusion beneath the hedging was unmistakable. A mid-ocean supply submarine could be worth several combat submarines in terms of the additional offensive capacity it unlocked. The numbers were compelling. The concept that emerged from these discussions was not immediately or universally welcomed inside the Kriegsmarine. There were officers who argued that converting submarine hull capacity to logistics was a waste of a weapon, that every boat built to carry fuel was a boat not built to carry torpedoes, and that the direct arithmetic of offensive power was being sacrificed for an indirect and uncertain gain. The German submarine construction program was already under pressure from competing industrial priorities, and the idea of dedicating hulls to supply rather than combat struck some senior officers as a luxury the Kriegsmarine could not afford. These were not foolish objections. They rested on a coherent strategic logic. They simply did not account for the efficiency data that Dönitz's staff had assembled, which showed not a marginal gain, but a potential multiplication of combat effectiveness. What gave the supply submarine concept its eventual momentum was precisely the rigor with which Dönitz and his staff had constructed the argument. This was not a romantic idea, not the vision of a single inspired officer pushing a pet project past resistant bureaucracy. It was a proposal built from operational records, fuel consumption tables, transit time analyses, and projected tonnage figures. It spoke the language that Berlin's planners and procurement officials understood, even if they did not always act on what they heard. The mathematics of the tonnage war, honestly examined, pointed towards a solution. The solution required a new kind of submarine, one that would never fire a torpedo in anger, one whose entire purpose was to keep the fighting boats fighting. Dönitz pushed for it with the same methodical intensity he brought to everything, and slowly, the argument accumulated sufficient weight to move. The men who worked closest to him in this period, the operations officers who mapped the rendezvous points on paper charts, the engineering staff who began sketching what a dedicated supply boat might carry and how it might transfer its cargo at sea, understood that they were working on something genuinely new. The logistics of submarine warfare at extended range had never been solved before, not by any navy, not at this scale. The British had not solved it. The Americans had not been required to solve it in the same way. Germany, fighting an ocean war from a coastline that placed its operational zones hundreds of nautical miles from its bases, was being forced to solve it by geography and by the unforgiving arithmetic of Dönitz's own strategic vision. The Milch Cow had not yet been built, and its crews had not yet been selected, and the hoses that would pass diesel fuel across the heaving surface of a North Atlantic Sea had not yet been coiled on any deck. But the idea was alive now, working its way through the machinery of the Kriegsmarine, gathering the force of institutional momentum. The question of what a submarine supply vessel might be was rapidly becoming the question of when the first one would sail. The question Dönitz had begun asking at the close of 1941 was not a simple one, and it did not receive a simple answer. What if the submarines never had to come home? To a staff officer conditioned to think in terms of gun angles and torpedo spreads, the question sounded almost philosophical. But inside U-boat headquarters, now operating from the French Atlantic coast, the men who understood the arithmetic of the campaign heard it differently. They heard it as an engineering problem, and engineering problems, given enough pressure and enough war, have a way of attracting solutions. The earliest serious proposals did not arrive fully formed. They emerged the way most wartime innovations do, through a series of uncomfortable conversations between operational commanders and design bureaus, between men who knew what the sea demanded and men who knew what steel could bear. The initial impulse was not to build an entirely new class of submarine. It was, as it so often is in wartime logistics, to adapt what already existed. The Type 9D hull was long, robust, and deep-keeled, a boat designed for extended oceanic operations, already one of the larger platforms the Kriegsmarine operated. Its internal volume, if you were willing to ask a heretical question, was considerable. And the heretical question being asked was this: what happens if you take the weapons out? To remove the forward torpedo armament from a combat submarine was not merely a technical act, it was a statement about what a submarine was for. The torpedo tube was the reason a U-boat existed in the minds of most officers who had come up through the surface navy and then crossed into the underwater arm. Removing those tubes, welding shut the apertures, stripping out the complex hydraulic loading mechanisms, clearing the compartments that had been designed around the geometry of a weapon, felt to some officers less like modification and more like desecration. This resistance would not disappear quietly, but the Design Bureau, working under the authority that the mounting losses of productive patrol time gave Dernitz's arguments, pressed forward regardless. What filled the space where torpedoes had been was stranger and, in its own way, more ambitious than anything a weapon could occupy. Enormous flexible fuel bladders, engineered to conform to the interior curves of the pressure hull, were fitted into the forward sections of the redesigned boat. These were not simple tanks bolted to a bulkhead. They were purpose-built structures, tested for pressure tolerance, and for the particular cruelty of Atlantic seas, capable of holding quantities of diesel fuel that dwarfed the operational reserves of any combat boat then in service. The engineering required to seal them against both the internal pressure of stored fuel and the external pressure of deep water was painstaking and, at several points in the design process, deeply uncertain. The men drawing the schematics knew that a failure of any one of these bladders at depth would not merely compromise the mission, it would end everyone aboard. Beyond fuel, the converted hull had to serve functions that no submarine had ever been asked to serve simultaneously. Food stores, and not merely the compressed rations that combat crews endured on short patrols, but genuine quantities of preserved and fresh provisions, enough to resupply crews who had been at sea for weeks, occupied dedicated lockers distributed along the length of the boat. Spare parts for the mechanical systems most likely to fail on an extended patrol were catalogued and stowed with a precision that more closely resembled a naval supply depot than a fighting vessel. Replacement torpedoes, the transfer of which across open ocean would become one of the most physically demanding acts of seamanship the crews of both vessels would ever perform, were carried in external containers along the upper casing and in modified internal stowage that required its own separate engineering solution. And then there was the medical bay, small, functional, positioned where it could be accessed without disrupting the rest of the boat's operations, equipped to handle the kinds of injuries and illnesses that accumulated on long patrols far from any port. In a campaign where a man with a burst appendix or a badly infected wound might otherwise mean an entire boat abandoning its patrol, even a modest surgical capability was a serious tactical asset. The resistance from within the Kriegsmarine had not gone silent while the Design Bureau worked. It had simply shifted its ground. The traditionalists who had objected to the principle now objected to the specifics. A boat that carried no torpedoes and could not dive deeply or quickly, its handling characteristics inevitably altered by the internal modifications, was not merely a non-combatant. It was, they argued, a liability. Surface in the Atlantic for long enough to transfer fuel and provisions, and you become a target. Every minute a submarine spent stationary on the surface was a minute in which it was vulnerable to aircraft, to destroyer patrols, to the kind of bad fortune that finds vessels that cannot maneuver freely. The officers making this argument were not wrong precisely. What they could not have known, in the early months of the design process, was quite how right they would eventually turn out to be. But that reckoning was still years away, and the immediate arithmetic of the tonnage war was more compelling than the speculative dangers of a program not yet built. There were also arguments about manpower. A combat U-boat required a crew trained in every dimension of offensive submarine warfare. A supply boat required something different. Men who understood machinery more than tactics, who could manage inventory and run transfer operations under difficult conditions, who could perform basic medical procedures in a space the size of a large wardrobe. Finding such men within the existing U-boat arm was not straightforward. The submariners who had risen through the system had risen because they were aggressive, tactically sharp, and oriented towards sinking ships. Asking them to spend their war passing fuel hoses to other men, who would then go and sink the ships, felt, to some, like being pulled out of the front line and assigned to drive supply trucks. The psychological dimension of this reorientation would prove to be a persistent feature of life aboard the Type 14, not a crisis, not a mutiny, but a low-grade unease that never entirely left the men who served on vessels that could not fight back. The design process moved through several iterations before settling into something approaching a final form. Early proposals were modified when testing revealed that the fuel bladder arrangements created structural stresses that the original hull geometry had not been designed to accommodate. The transfer hose systems went through at least 2 complete reconceptions before engineers produced a design that could realistically be operated by men on a heaving deck in Atlantic weather, in darkness, with 2 submarines rolling independently against each other in a 2 to 3 meter swell. The torpedo transfer method, passing weapons that were both heavy and precisely sensitive to impact between 2 vessels, required its own dedicated rigging system, and the procedure that eventually emerged was less a piece of naval engineering than a piece of choreography, requiring precise coordination between the crews of both boats and a level of seamanship that could not be improvised on the spot. All of this had to be thought through at a desk, in peacetime conditions, by men who could only imagine what the Atlantic would feel like when the time came. The arguments about hull type deserve a brief pause, because the choice was not as obvious as it might seem in retrospect. The Type 9D was selected not only for its size but for its operational range. It was already the Kriegsmarine's long-distance boat, built for the South Atlantic and beyond. Converting a shorter-ranged hull would have defeated much of the purpose. But the IXD's dimensions also imposed constraints on what could be carried and how the interior could be reconfigured, and those constraints shaped the final design in ways that would later have operational consequences. The boat that emerged from this process was genuinely novel, a purpose-built submarine supply vessel with no direct precedent in any Navy's inventory, but it was also a compromise between what the engineers wanted to build and what the existing hull would allow them to build. When approval finally came from Berlin, it was not accompanied by the kind of fanfare that greeted new weapon systems. There were no public announcements, no photographs released to the naval press, no formal ceremony. The Type 14 was classified from the outset, and the details of its construction and purpose were kept tightly held within the upper levels of the Kriegsmarine's planning apparatus. A total of 10 boats were eventually ordered across the program, though not all of them would be authorized at once. The first approval was for a small initial batch, enough to test the concept operationally without committing the full shipyard capacity that 10 boats would require. It was a cautious beginning to what was, in its way, a radical idea. The nickname came later, informally, from the men who built them and the men who would eventually serve on them. Milch Cow. It was the kind of name that could only have been invented by people who understood the actual function of the vessel rather than its classification on an official document. A milk cow was not a glamorous animal. It was not a predator. It was something patient and essential, something that other creatures depended on, something whose value was measured not in the drama of what it did, but in the steady, unglamorous reliability with which it sustained everything around it. The men who first used the name probably did not intend it as flattery. In time, it would become something more complicated than that, a label that carried within it the entire ambiguity of a vessel that was indispensable, invisible, and, in the end, doomed precisely because of how much everything else needed it to survive. The order had been given. Somewhere in the bureaucratic machinery of the Kriegsmarine, approval had moved from concept to command, and now the shipyards had to answer a question that no naval engineer had seriously faced before. How do you build a submarine that is not, in any meaningful sense, a weapon? The answer would take months of work, compromise, and argument on drafting tables across occupied Europe. It would produce a vessel unlike anything that had gone before it, ungainly by the standards of the sleek grey wolves it was built to serve, but carrying within its pressure hull an idea that could reshape the entire arithmetic of the Atlantic War. The men who would build it had no template to follow. They were inventing as they went. The hull chosen as the basis for the Type 14 was derived from the existing Type 9ED design, a large ocean-going submarine already proven capable of extended-range operations. But the conversion was not merely a matter of stripping out weapons and filling the space with fuel. The fundamental geometry of a submarine pressure hull resists modification with something close to stubbornness. Every cubic meter that was surrendered to a diesel fuel bladder was a cubic meter taken from trim tanks, from ballast, from the structural mathematics that kept a submarine from either floating helplessly on the surface or diving beyond its crush depth. The engineers had to solve these equations simultaneously, redistributing weight and buoyancy across a hull that was now asked to carry burdens it had never been designed for. Hull sections were redesigned and strengthened to accommodate the additional fuel loads. Ballast configurations were recalculated from first principles. It was painstaking, exacting work done against a clock that Dernitz's operational demands were winding tighter with every passing week. The fuel capacity that emerged from this engineering effort was staggering for its era. A fully laden Type 14 could carry several hundred tons of diesel fuel in addition to its own propulsion reserves, enough to replenish multiple combat U-boats without itself returning to port. To achieve this, the interior of the boat was transformed. Where torpedo storage rooms and reload racks would have occupied the forward sections of a combat submarine, the Type 14 had fuel compartments, storage bays, and the mechanical infrastructure of a floating supply depot. The torpedo tubes themselves were not installed in the forward position at all, a design decision that was both practically necessary and symbolically total. This boat was not going to fight. It was going to feed. The distinction was built into the steel. The transfer hose systems required to move fuel across open water between two submarines presented their own set of engineering puzzles. Unlike a surface tanker replenishing a warship in a sheltered anchorage, a milk cow would be operating in the Atlantic, a body of water not known for its patience with complex operations conducted on its surface. The hoses had to be robust enough to withstand the constant motion of two hulls moving independently in ocean swells, yet flexible enough to snake across the gap between them without kinking or tearing. Fittings had to seal under pressure, while simultaneously being operable by men wearing gloves on a wet and rolling deck. The pumping systems had to move fuel quickly. Every minute spent stationary on the surface was a minute of exposure, but not so forcefully that they overwhelmed connections on the receiving boat's side. These were bespoke solutions, designed specifically for this vessel and this task, and getting them right required iteration that only real sea trials could provide. The engineers knew the ocean would have the final word. Beyond fuel, the Type 14 was configured to carry torpedoes for transfer to combat boats, and this presented a handling challenge of an entirely different order. Moving a torpedo in harbor, with cranes and steady footing, is demanding enough. Moving one between two submarines on the open ocean, both vessels rising and falling with the sea, both crews straining on lines and handling gear with hands that had likely been wet for days. That required specially designed deck handling equipment, practiced crew coordination, and a level of seamanship that pushed even experienced submariners to their limits. Storage arrangements aboard the Milch Cow were engineered to allow torpedoes to be moved to the deck casing in a controlled sequence. Every element of the system was thought through in advance, because out in the Atlantic, there would be no opportunity to improvise without cost. Beyond the mechanical, the Type 14 also incorporated a small but dedicated medical bay, a feature absent from virtually every combat submarine in the German fleet. U-boat crews developed injuries and illnesses far from any port, and in a war of extended patrols, a man with a serious infection or a broken bone was a liability to his boat and a danger to himself. The Milch Cow's medical capability was modest by hospital standards, but it was genuine. Space had been carved out of the already pressured interior to accommodate a treatment area and medical stores. The men who staffed it were qualified medical personnel assigned specifically to the supply boat role. It was a detail that said something about the ambition of the program. The Milch Cow was not just supposed to extend U-boat patrols, It was supposed to sustain the human beings conducting them. 10 Type 14 boats were eventually ordered. The number was not arrived at arbitrarily. It reflected Dernitz's calculations about the minimum supply infrastructure needed to support sustained wolfpack operations across the expanded patrol zones the milk cows were intended to open. Whether 10 would ever prove sufficient was a question the future would answer with brutal clarity, but at the moment of ordering, they represented an investment of significant shipyard capacity that Germany could not easily afford. Each boat required skilled labor, specialist materials, and extended construction time. The yards worked under pressure, the sort of pressure that produced shortcuts when it should have produced care, and yet the vessels that emerged were, by the standards of wartime submarine construction, genuinely well-built instruments for their unglamorous purpose. The men selected to crew these boats were a deliberate departure from the profile of the combat U-boat sailor. A milk cow required fewer torpedo specialists, and more men whose skills lay in engineering, maintenance, and logistics. Diesel mechanics who could diagnose a fault in a combat boat's propulsion system from description alone, because they might be asked to do exactly that in the middle of the ocean. Electricians, hydraulics specialists, experienced medical staff. The crew complement was smaller than a comparable combat submarine, partly because the offensive weapon systems that demanded so many hands had been removed, and partly because the work the milk cow performed, weighting, transferring, maintaining, did not require the same density of fighting men that a wolfpack attack demanded. These were specialists chosen for competence rather than aggression, and that distinction shaped the entire culture aboard. For many of these men, the psychological landscape of the assignment was complicated from the beginning. The prestige in the U-boat arm flowed to the commanders who sank tonnage, the men whose patrol logs filled with kills, whose names appeared in German news reports, whose faces appeared beneath peaked caps in photographs, distributed to a public hungry for heroes. The milk cow crews had none of that. Their kills were counted in liters, transferred, and torpedoes passed across a heaving deck. Their victories were measured in patrols extended, in combat boats that came alongside running low and departed running full. It was essential work that the entire strategy depended upon, but it existed in the narrative shadow of the men they served. Some milk cow sailors took a quiet pride in the indispensable nature of what they did. Others struggled to locate themselves within a military culture that measured worth in enemy tonnage sent to the bottom. There was also the matter of being unarmed. A combat U-boat was never an easy target. It could fight back with torpedoes, dive deep, maneuver aggressively. The Type 14 had none of these options. It carried anti-aircraft guns for surface defense, light weapons that were better than nothing and worse than anything the aircraft attacking them would carry. In the event of a serious threat, the milk cow's best option was to dive quickly and go deep. But a boat laden with fuel and stores did not dive like a combat vessel. The weight affected everything. Sailors aboard the Type 14 understood, at some level that most of them probably preferred not to examine too directly, that if the war came to find them, they would be facing it with significantly diminished means of response. The knowledge did not stop men from volunteering, but it colored the silence in the mess room when the conversation turned to what Allied aircraft were capable of finding. When the first Type 14 boats left the shipyard slipways and entered the water for trials, they looked different from every other submarine in the Kriegsmarine. Broader in the beam, lower in the water when fully laden, with a deck casing designed around transfer operations rather than torpedo handling. They were not graceful in the way the sleek Type 6 were graceful. They had the utilitarian, purposeful appearance of machines built to do a specific job rather than to embody any aesthetic of war. Harbor workers who watched them being fitted out sometimes asked what they were for, because nothing about them looked like what a submarine was supposed to look like. The men who would sail them could have given several answers. The truest one was simple. They were built to keep the grey wolves alive. Everything else, every rivet and weld and carefully engineered transfer fitting, existed in service of that single, cold, and entirely serious purpose. When the first milk cow slipped out of its French base and nosed into the grey Atlantic, it carried something more valuable than torpedoes. It carried time. Every litre of diesel fuel packed into its swollen internal bladders represented another hour a combat U-boat could spend hunting rather than running for home. Every spare torpedo lashed into its purpose-built racks was a kill that might otherwise never happen. The men aboard understood the arithmetic, even if they did not yet understand the ocean that was about to test them. They were sailing into a role that had no precedent, with procedures that existed only on paper and rendezvous plans that assumed the Atlantic would cooperate. It would not always. The rendezvous system was, by any measure, an extraordinary piece of operational engineering. U-boat command divided the Atlantic into a grid of lettered and numbered squares, each square covering a patch of ocean large enough to search, yet small enough to make a meeting between two submerged vessels achievable within a reasonable window. A combat boat in need of fuel would radio its position and requirements, encrypted through the Enigma machine, and headquarters would reply with a designated square, a time window, and a frequency schedule. The milk cow, having received its own set of orders, would plot a course and submerge, traveling as much of the distance as possible beneath the surface to reduce the risk of aerial sighting. As the rendezvous window approached, both vessels would surface, establish visual contact, and then begin the slow, careful business of bringing themselves alongside each other in open water. On paper, it was elegant. On the ocean, it was something else entirely. The seamanship required for an open ocean submarine transfer had no real equivalent in any naval manual. Two vessels, each displacing hundreds of tons, each designed to move through water rather than sit still on top of it, had to be held in close proximity while hoses were run between them and heavy equipment was manhandled across the gap. The Atlantic rarely offered calm conditions as a courtesy. Swells could run to several meters even in moderate weather, and the motion between two submarines sitting beam on to the sea could open and close the distance between them violently within seconds. Fenders were rigged along the outer casing, and lines were run fore and aft to hold the boats in rough alignment. But the men working the transfer lived permanently one bad wave away from being crushed between the hulls or swept into the water. There were no rescue procedures worth speaking of. The ocean made no concessions for the novelty of what was being attempted. Yet the transfers worked. Diesel fuel moved first, drawn through flexible hoses from the milk cow's storage tanks into the waiting combat boat's bunkers, the process taking anywhere from several hours to the better part of a day, depending on how depleted the receiving vessel was. The fuel transfer required constant attention. Pressure had to be managed, blockages cleared, connections checked for leaks, and the engineering crews on both boats worked through the entire operation without rotation, because the alternative was stopping. Torpedoes came next when they were needed, and this was the element of the transfer that tested everyone most severely. A torpedo weighs more than a ton, moving one across a heaving gap of open water between two submarines, using nothing more sophisticated than block and tackle rigs, hand lines, and the coordinated muscle of a dozen men, required the kind of precise timing that could not be drilled on land. The men who managed it successfully, patrol after patrol, in conditions that ranged from uncomfortable to genuinely dangerous, had earned something they were never entirely given credit for. What the milk cows carried went beyond fuel and weapons, and this is the part of the story that tends to get lost in the operational summaries. Tucked into every available space aboard the supply boats were provisions, tinned food in bulk, but also perishables carried specifically because the combat crews had been living on iron rations for weeks, fresh vegetables, fruit when it could be sourced, and bread. The milk cows baked their own bread aboard, using compact galley equipment that was primitive but functional, and the loaves were passed across in canvas bags during transfers, one boat to another, in the middle of the Atlantic Ocean. For a combat U-boat crew that had been eating stale hardtack and tinned meat in a steel tube for 30 or 40 days, the smell of fresh bread arriving from across the water was not a small thing. It was, by every account that has survived, one of the moments that broke through the grinding routine of submarine warfare and reminded the men that someone, somewhere, had thought about them as human beings rather than weapons systems. Medical support was another layer of the Milch Cow's role that the original design had incorporated, but that took on a specific weight in practice. Combat U-boats carried no dedicated medical officer on most patrols. A qualified senior rating handled injuries as best he could, which was often not very well. The Milch Cows, by contrast, carried personnel with genuine medical training, a small sick bay with basic surgical capability, and the drugs and equipment to treat injuries that would otherwise simply have to be endured until the boat returned to base. Men with infected wounds, broken bones sustained in depth charge attacks, and a range of medical emergencies that had been accumulating across long patrols were brought across to the supply boat, treated, and in some cases recovered sufficiently to return to their own vessel before the transfer was complete. The supply submarine as a floating aid station was not a planned strategic function. It was something that emerged from operational reality, and it mattered to the men in ways that no tonnage calculation could capture. Mail was the last thing transferred, and perhaps the strangest. Letters from home had accumulated at the French bases, sorted and bundled and loaded onto the Milch Cow before departure, addressed to men on combat boats, whose patrol positions were known only approximately. When the transfer began and the lines went across, the mail sacks went with them, a bundle of handwritten pages crossing an ocean in a canvas bag on a rope, from a supply submarine to a combat submarine, somewhere in the mid-Atlantic. There are accounts of men sitting in the forward torpedo room of a combat U-boat, fresh bread in one hand and a letter from a wife or mother in the other, reading in the faint light while the fuel transfer continued on the casing above them. The Milch Cow had not been designed to carry hope, but that is what it turned out to be carrying as much as anything else. The strategic effect of the first operational deployments was immediate and measurable, and it shocked even the officers at U-boat headquarters who had done the arithmetic on paper. Combat boats that had previously been limited to the North Atlantic shipping lanes, because going further simply consumed too much fuel, were now ranging south into the tropical waters of the South Atlantic, where the convoy infrastructure was thinner and Allied anti-submarine forces had not yet adjusted to a threat from submarines operating at those distances. The Caribbean became accessible in sustained operational terms for the first time. U-boats were hunting off the coasts of South America, in the waters around the Caribbean islands, and pushing towards the supply routes that connected Britain not just to North America, but to the whole southern hemisphere. Each of these extensions was, at its root, a Milch Cow transfer, a meeting in a grid square, a hose run across the water, a fuel quantity that turned a retreating submarine into a hunting one. The patrol durations that emerged from the first full cycle of Milch Cow-supported operations were almost unrecognizable compared to what had come before. A combat U-boat that might previously have spent 20 days in transit for every 10 days of effective patrol time could now, with a single mid-ocean transfer, double or triple its time in the hunting area. 2 transfers in a single patrol, which the more aggressive patrol planning began to incorporate as standard, extended range further still. The boats themselves had not changed. The ocean had not changed. Only the logistics chain had changed, and that change was rewriting the operational map of the Atlantic in real time, opening waters that Allied planners had categorized as safe simply because they had believed no U-boat could reach them. The men coordinating these transfers from within U-boat headquarters watched the patrol reports come back and understood that something genuinely new was happening. Boats were checking in from positions that had been theoretical 6 months earlier. Tonnage was being sunk in ocean areas that had never appeared on the operational loss maps. The Milch Cow commanders, for their part, were developing a body of practical knowledge about how to manage transfers in varying sea states, how to shorten the time spent surfaced, and how to maintain radio discipline without compromising the coordination that made the rendezvous possible. It was improvised expertise, built patrol by patrol, and never written down in a form that could be easily transmitted or preserved. The men learned it by doing it, in the middle of the ocean, under time pressure, and they became very good at it. What the Milch Cows had done in those first months of operational deployment was solve a problem that had seemed fundamental. Dönitz had looked at the Atlantic and seen an ocean too large for his submarines to dominate without exhausting themselves simply crossing it. His supply boats had turned that crossing into a non-event, a brief surface transfer, a logistics pause, and then the combat boat was back in action with full tanks, fresh weapons, and, not insignificantly, a bag of bread and news from home. The ocean had not shrunk, but the reach of the grey wolves had grown enormously, and the Allied shipping routes that wound through those suddenly accessible waters were about to bear the full weight of that change. Somewhere below the surface, running south with full bunkers, the hunters were already moving into their new territory, and the ocean that had previously protected those routes by virtue of sheer distance was protecting them no longer. For 2 years, the Atlantic had been the killing ground, but in the opening weeks of 1942, the war came to a coastline that had never truly expected it, and the men who brought it there did so because, for the first time, they had enough fuel to make the journey and enough torpedoes waiting in the dark to finish the work. Operation Paukenschlag, translated loosely as drumbeat, or the strike of a drumstick, was Admiral Karl Dönitz's answer to America's entry into the war. When the United States formally joined the conflict in December of 1941, Dönitz saw not just a new enemy, but a new hunting ground, one whose coastal shipping lanes were undefended, whose port cities blazed with light through the night, and whose merchant mariners had no experience of submarine warfare in their own waters. The problem was distance. The American eastern seaboard lay more than 3,000 nautical miles from the U-boat bases along the French Atlantic coast. A standard combat boat making the crossing at economical speed would arrive with barely enough fuel to operate and would need to turn for home almost as soon as the hunting began. Without a solution to that arithmetic, Paukenschlag would be a gesture rather than a campaign. The Milch Cow changed the arithmetic entirely. Positioned in carefully selected mid-ocean grid squares, far enough from both coasts to reduce interception risk, precisely calculated to be within reach of boats outbound from France, a single Type 14 supply submarine could replenish multiple combat boats in sequence over a matter of days. A U-boat commander who crossed the mid-Atlantic and met a Milch Cow at the rendezvous point did not need to calculate his return journey from that moment. He could top off his fuel tanks, take on additional torpedoes, collect food and medical supplies, and then press on westward, knowing that the Milch Cow would be waiting for him again on the return leg if he needed it. The patrol no longer had a natural turning point imposed by logistics. It lasted as long as the torpedoes and the hunting. What followed along the American coast in the early months of 1942 was, from the German perspective, a campaign of extraordinary and almost undisturbed success. Allied merchant mariners who had survived the convoy battles of the North Atlantic now found themselves sailing independently along a coastline that offered no organized convoy system, no coordinated air patrol, and no effective coordination between naval and civilian authorities about whether to dim the lights of the resort towns and port cities that illuminated ships on the horizon for any submarine watching from offshore. Tankers and cargo ships moved at predictable speeds along predictable routes, silhouetted against the glow of cities that had not yet absorbed the reality of war. U-boat commanders described approaching these ships not through the disciplined geometry of a convoy attack, but almost casually, choosing their targets from an abundance that their North Atlantic experience had never quite prepared them for. The tonnage losses during this period were staggering. Month after month through the spring of 1942, Allied shipping losses in the Western Atlantic and Caribbean reached figures that alarmed even those within the British Admiralty, who had spent 2 years watching the North Atlantic campaign. Tankers carrying oil from the Gulf of Mexico to refineries on the eastern seaboard were particularly vulnerable, and their loss created fuel shortages that rippled far inland, affecting the industrial output of a nation still converting itself to a war economy. Sailors died within sight of American soil. Bodies and wreckage washed onto beaches where civilians were walking their dogs in the morning. The gap between the abstract war reported in newspapers and the concrete evidence of destruction on the shoreline closed with brutal speed. German submariners of this period later referred to it as the second happy time, the first having been the early months of the North Atlantic campaign before Britain's convoy system hardened. But unlike that earlier period, which had been limited by the reach of the boats available, the second happy time was sustained by the supply chain that the milk cows made possible. Combat boats that would have needed to abort their patrols after 2 or 3 weeks of operations off the American coast were instead replenished at sea and sent back in. A boat that exhausted its torpedoes could, in some circumstances, receive a partial reload during a mid-ocean rendezvous and return to the hunting grounds, rather than running empty back to France. The milk cow was not merely extending individual patrols, it was multiplying the effective presence of the entire U-boat fleet in waters where that presence was devastating Allied commerce. The logistical chain that made this possible was, by the standards of submarine warfare in any era, a remarkable exercise in operational planning. From the Biscay bases, combat boats departed on carefully staged schedules, their fuel loads calculated to reach the rendezvous point with a workable reserve. The Type 14 waited at the assigned grid square, having already completed its own transit from a French port, carrying enough diesel to service multiple boats across several days of transfers. After each rendezvous, the combat boat pressed westward. The milk cow, riding low with the weight of its cargo, held position or moved slowly along a prearranged track, waiting for the next boat to arrive. When its fuel and stores were exhausted, it returned to France to reload and repeat the cycle. At peak efficiency in the spring and early summer of 1942, this system was operating with a regularity that Dönitz's staff had hoped for, but perhaps not fully dared to expect. The Caribbean and Gulf of Mexico became extensions of this same operational reach. U-boats refueled in mid-ocean pressed not just to the American eastern seaboard, but into the confined and extraordinarily productive shipping lanes of the Caribbean, where oil from Venezuelan fields moved toward American and British ports in a steady, vulnerable stream. The shallow coastal waters and the density of traffic made these areas extraordinarily dangerous for Allied shipping, and the combination of milk cow support and the absence of an effective convoy system in those waters produced losses that threatened, at their worst, to outpace even the dark months of 1941 in the North Atlantic. Dönitz's tonnage calculus, his conviction that sinking Allied ships faster than they could be built would eventually tip the balance, seemed, in this season, to be tracking toward vindication. There was a quality to the early Paukenschlag period that existed nowhere else in the U-boat war, a kind of operational freedom that the North Atlantic had never quite offered. In the North Atlantic, every patrol was measured against the hardening resistance of an adversary who had been learning, adapting, and suffering for 2 years. Off the American coast, the adversary was still learning the first lessons. The milk cow had not created this vulnerability. American unpreparedness and the absence of convoy organization were its root causes, but the supply submarine had ensured that German combat boats arrived with full tanks and full torpedo rooms and stayed long enough to exploit every hour of that vulnerability before it closed. Without the mid-ocean refueling capability, the American campaign would have been a series of brief, lethal raids. With it, the raids became a sustained offensive. The men aboard the milk cows during this period knew something of what they were enabling, though the precise operational picture was never shared widely below command level. Supply boat crews could calculate from the volumes they were transferring and the number of boats they were servicing that the combat submarines they were feeding were operating at extended range in profitable hunting grounds. The mood in the mid-ocean rendezvous was, by most accounts from this period, one of genuine purpose. The knowledge that the careful, unglamorous work of holding a transfer hose in Atlantic swells at 2 in the morning was directly connected to results that U-boat command was reporting with satisfaction to Berlin. The Milch Cow crews had not fired the torpedoes, but they had made the firing possible. The Allies were losing ships at a rate that had no precedent in the Western Atlantic, and for several months they did not fully understand why. The extended endurance of U-boat patrols in American waters was not consistent with what Allied analysts knew about the fuel capacity of German submarine types. Something was sustaining these boats beyond their calculated range, keeping them on station longer than they should have been able to remain, sending them into waters that geography seemed to place beyond their practical reach. The answer was out there somewhere in the mid-Atlantic, surfacing at night to pass fuel through hoses across a dark and indifferent sea. The Allies would eventually find it, but in the spring of 1942, as ships burned on the horizon of a coastline still blinking with peacetime light, the Milch Cow was doing precisely what it had been built to do, and the tonnage war, for one brief and terrible season, seemed to be running exactly as Dönitz had always believed it could. There exists a peculiar kind of courage that requires you to do nothing at all. The men who served aboard the Type 14 submarines, the Milch Cows, learned this truth in the darkest hours of their service. Unlike their counterparts on the combat boats, where a crew of 45 or 52 souls hunted merchant vessels across thousands of kilometers of Atlantic swell, the supply submariners occupied a different universe entirely. Their boat was not a weapon in the conventional sense. It was a supply depot that happened to dive. It was a bakery beneath the waves. It was a floating hospital, a fuel storage facility, a torpedo magazine, and a grave risk to every man aboard, precisely because of what it could not do. The moment a Type 14 surfaced, and surface it had to do, repeatedly, for hours at a stretch, it became vulnerable to every threat the Allies could deploy. It could not dive quickly with transfer hoses still attached. It could not maneuver with a combat U-boat lashed alongside. It could not fight back. To serve on such a vessel required a different temperament than that demanded of torpedo officers or lookouts scanning the horizon for merchant smoke. It required men who could live with the knowledge that their contribution was essential but invisible, that they would face danger without the compensating satisfaction of seeing an enemy destroyed, and that if a Milch Cow was found, escape would be nearly impossible. The physical reality of life inside a Type 14 submarine began the moment a crew member climbed through the conning tower hatch and descended into the main pressure hull. The boat was 251 feet in length, with a beam of just over 23 feet. 48 cubic meters of usable internal volume had to accommodate 54 men, their food, their water, their air regeneration equipment, and the vast quantities of cargo that defined the Milch Cow's purpose. A standard combat Type 9D submarine carried sufficient supplies for approximately 80 days at sea. The Type 14 carried supplies for 120 days, but not for its own consumption. Most of what filled the hull belonged to other boats. The forward torpedo room, which on a conventional U-boat housed 4 or 5 enormous 21-inch torpedoes in their tubes, and others racked vertically or horizontally in storage racks, now held only spare torpedoes meant to be transferred to other submarines. Where there had once been room to move among the weapons, there were now tightly packed cylindrical containers of diesel fuel, stacked horizontally and secured with webbing and clamps. The diesel fuel itself came in several forms, some in drums that had to be manually decanted into transfer containers, some in flexible bladders installed within the hull spaces themselves, creating a honeycomb of cargo where every cubic centimeter had been claimed by the supply mission. To walk forward into this space was to move through a landscape of metal and petroleum, stepping over hoses and cables, running your hands along cold steel ribs of the pressure hull, already breathing air that held the sharp tang of diesel and the underlying sweetness of engine oil. The crew's sleeping quarters reflected the sacrifice of space to storage with brutal efficiency. In a standard U-boat, bunks were tiered 3 high in certain compartments, with each sailor entitled to a small locker and perhaps a thin shelf for personal possessions. On a Milch Cow, sleeping arrangements had been further compressed. Many sailors had no assigned bunk at all. They worked watch rotations where they might occupy a bunk for only 4 hours before their crewmate, working the opposite watch, needed that same narrow space. The phenomenon was called a hot bunk, and it was profoundly disorienting. You did not think of the bunk as yours. You inherited it body warm from whoever had just climbed out, and you would lose it just as quickly when your watch ended. The mattress was thin, the blanket thinner still, and above you, just inches from your face, lay the torpedo racks, fuel containers, and the curved hull plating itself. You learned to sleep in a particular posture, crammed against the hull, your arm numb under your head within minutes. You learned not to dream, or to forget your dreams the instant you woke. The perpetual hum of ventilation, the subtle thrumming of the diesel engines if you were on the surface, and the occasional groan of the hull itself as pressures shifted, meant that silence was something that existed only in memory, in the world above the water. The galley, tucked into one of the compartments amidships, represented one of the few spaces where the Milch Cow concept intersected with something approaching human dignity. There was a small electric stove, a refrigerator powered by the boat's batteries when submerged, and its engines when surfaced, a sink with salt water and precious freshwater taps, and a work surface where the boat's baker, a man specifically trained for this role, would begin his work 4 hours before dawn, most days. On a Type 14, the baker was a critical member of the crew. He was not subordinate to the cook, though the 2 men worked in close coordination. The baker's job was to maintain the morale of 54 men crammed into a metal tube by providing them with fresh bread. He would prepare dough each evening, allowing it to rise overnight in a warm corner of the galley, where heat could reach it without being noticed by officers concerned with energy conservation. In the hours before dawn, he would shape loaves, proof them briefly, and slide them into the small electric oven. By the time the crew began to stir for breakfast, the smell of baking bread had permeated multiple compartments of the boat. This was not an accident. The Kriegsmarine understood, at some level, that the human mind required comfort alongside discipline, and the smell of warm bread rising through the boat's atmosphere was a profound comfort when everything else spoke of constraint and danger. The baker himself became a figure of respect and mild celebrity. Men would linger in the galley longer than their watch duties justified, drawn by the promise of a warm slice and the normality that fresh bread represented. The baker also baked extra loaves specifically meant to be transferred to the waiting combat boats. Canvas bags of still warm loaves passed hand over hand across the gap between submarines. Each bag a small gesture of solidarity from the crew that could not fight to the crews who would. The daily rhythm aboard a Milch Cow was governed by the watch rotation and the operational demands of whatever moment the boat occupied. When surfaced and moving toward a rendezvous point, the boat ran on diesel engines, charging its batteries and covering distance as quickly as it could manage, typically 9 or 10 knots, faster than was ideal for a submarine, but necessary to reach predetermined positions on time. The watch rotation aboard a Type 14 was typically 4 hours on, 8 hours off, though this was flexible based on operational demands. When you were on watch in the conning tower, you scanned the horizon with binoculars, maintained the boat's course, logged weather conditions and sea state, and listened to the radio operator reporting any intercepts from Allied search patterns or German command broadcasts. When you were off watch, you were ostensibly resting in your hot bunk, but many sailors used this time to maintain their equipment, study operational manuals, write letters they hoped would somehow reach home, or simply sit in the galley nursing a cup of weak acorn coffee, real coffee being too valuable a commodity to waste on a supply boat that was not expected to return to port. The boat's officers, the commanding officer, the first watch officer, The chief engineer, the torpedo officer, and the boat's doctor maintained separate quarters. Their cabins were fractionally larger than crew bunks, which mainly meant they could extend their legs when lying down. They bore their own weight of psychological stress, knowing that they commanded a vessel that was essential to the fleet, but increasingly expendable, a vessel whose loss would be lamented by the fleet it served, but quickly forgotten by history. The moment a rendezvous approached, the entire pace and character of life aboard shifted. When the Milch Cow received its call from a waiting combat U-boat, transmitted by radio in carefully coded language designed to evade Allied direction finding, the crew moved into a different state of alertness. The boat would reduce speed, begin evasive maneuvers intended to throw off any Allied hunter-killer group that might be tracking the radio transmission, and maneuver to the prearranged grid square. The rendezvous itself was an extraordinary feat of seamanship. Two submarines had to locate each other in an area of ocean several kilometers across, maneuver to within a few meters of each other, and maintain position relative to one another while stationary on the surface, a state of extraordinary vulnerability. The Milch Cow's crew would launch a rubber dinghy and string a rope line between the two boats, establishing a working platform in the gap between the hulls. Sailors from both boats would hand-pass fuel hoses across this gap. Then the diesel fuel would flow from the Milch Cow's tanks into the waiting boat's bunkers. The process was painfully slow, constrained by the capacity of the hoses and the amount of fuel the receiving submarine could accept without exceeding its trim. A full transfer could take 4 to 6 hours. During this entire period, both submarines were trapped on the surface, unable to dive, unable to escape, their radio silence now broken by the traffic of another boat's urgent reports coming through the same waters. The men performing the transfer work, the bosun's mates and the machinist's mates on both boats, moved across the swaying rubber dinghy in the dark, handling heavy hoses that carried thousands of liters of diesel, their hands freezing in the spray, their attention divided between the technical demands of their work and the distant sound of aircraft engines that might signal the end of everything. The Milch Cow's doctor occupied a particularly strange position within this compressed world. The boat carried a small medical bay, no more than a closet by civilian standards, equipped with instruments and medicines, meant not primarily for the Type 14's own crew, but for wounded or sick sailors from the combat boats that would rendezvous with the supply submarine. German U-boat doctrine anticipated that combat submarines would suffer casualties, that men would be wounded in depth charge attacks, or infected with wounds that could not be properly treated aboard a crowded combat boat. The Milch Cow, being somewhat larger and intended to be less exposed to combat damage, could theoretically provide medical treatment and hold a wounded sailor until he could be transferred back to France aboard a faster boat making the return journey. The doctor would spend his off-watch hours maintaining his instruments, reviewing medical texts in a shared cabin, and occasionally emerging to treat minor illnesses affecting the crew, infections, digestive complaints, the psychological strain that manifested as physical symptoms in men who lived beneath the sea, in constant awareness of their vulnerability. When a combat boat arrived with wounded aboard, the doctor's status transformed instantaneously. He became the most critical person on the vessel. He would treat wounds in the confines of the medical bay while the boat remained on the surface, exposed and unable to dive, with every moment of treatment adding to the window of opportunity for an Allied patrol aircraft to detect them. The food aboard a Type 14 reflected the boat's unusual nature. The Type 14 carried more food per man than most combat U-boats, but it was the supply boat's own crew that ate it, not the vessels they served. German U-boat crews were fed reasonably well by the standards of the Kriegsmarine: bread, margarine, processed cheese, tinned meat, dried vegetables reconstituted in hot water, and the occasional luxury like real chocolate. A Milch Cow's crew ate slightly better than typical combat crews, having somewhat more access to fresh provisions, though by the time a supply submarine reached the mid-Atlantic rendezvous point, everything was either tinned or dried. The galley crew, the cook and his assistant, maintained rotation schedules intended to provide 3 meals daily, though mealtimes were flexible based on watch rotations. Breakfast was typically weak coffee and bread, with margarine and cheese. Lunch was soup with dried vegetables and bread. Dinner was some form of preserved meat, corned beef, sausage, tinned fish, prepared with whatever fresh provisions could be salvaged from the stores meant for transfer. The psychological impact of food in such an environment was outsized. Mealtimes represented social events, moments when sailors could gather outside their compartments, moments when conversation was possible without needing to shout over machinery, moments that approximated normalcy. The cook understood this with an almost professional intensity. He would take extraordinary efforts to vary the meals, despite the constraint of limited ingredients, rotating spice combinations, presenting the same corned beef in 5 different preparations across a week, occasionally constructing actual desserts from tinned fruits and ship's biscuits. These efforts were not wasted on a crew that appreciated them as gestures toward civilization, in an environment where civilization had been stripped to its minimum possible expression. The psychological texture of life aboard a milk cow rested on a peculiar contradiction. The men serving on these boats were, without exception, volunteers. The Kriegsmarine did not assign men to the Type 14 fleet. It selected them from existing U-boat crews and from training pools, offering them the opportunity to serve in a logistics role. The motivation for volunteering varied. Some men volunteered because they had reached a point of exhaustion and hoped that supply boat service might be slightly less dangerous than combat patrols. Some volunteered for purely practical reasons. Perhaps they had connections to a particular Type 14 captain or crew and chose to follow them. Some men, a smaller number, volunteered because they had thought through the strategic logic of the milk cow program and decided that their contribution would be greatest in a support role, that sinking ships indirectly by extending the patrol range of combat boats was more efficient than sinking ships directly. But nearly all of them, once aboard and serving through their first patrol, experienced a complex emotional state that combined pride with a strange variety of shame. The pride was straightforward. The Type 14 crews knew that their work was essential, that without them, the combat boats could not operate in distant waters, that every ship sunk off the American coast or in the Indian Ocean bore some portion of credit to the men who had kept the combat boats fueled and fed. But the shame was more subtle and perhaps more corrosive. These men had not joined the Kriegsmarine to serve as fuel technicians and supply coordinators. They had joined expecting to participate in combat operations, to witness the destruction of enemy shipping, to see the visible results of their efforts. On a milk cow, you did none of these things. You saw only the other boats, the faces of sailors you had never met, the stress and exhaustion in the eyes of men who had been hunting and being hunted. You never saw an enemy ship. You never heard the sound of an impact as a torpedo struck a target. You were peripheral to the war that everyone else was fighting. This peripherality created a strange social dynamic within the Type 14 crews. The men aboard these boats were simultaneously essential to the war effort and excluded from its visible operations. They lived with the knowledge that they had given up the chance to participate. In the spring of 1942, something was happening that should not have been possible. Across the North Atlantic and further south, beyond the reach of land-based aircraft, Allied merchant ships were sinking at positions and during time periods that contradicted everything the naval intelligence services understood about U-boat capability. A tanker would go down off the coast of West Africa. A week later, 3 cargo vessels would be lost southeast of Bermuda. Then a passenger ship, listing and burning, would be spotted nearly 800 kilometers south of the Azores, all within a single patrol cycle that should have exhausted any submarine's fuel reserves long before it could reach such distant hunting grounds. The dates did not align with calculated transit times. The tonnage being sunk was too distributed, too far-flung, suggesting not one U-boat operating an impossible patrol pattern, but rather multiple submarines somehow resupplied at sea, their endurance artificially extended far beyond the theoretical maximums that had governed all previous calculations. The men tasked with solving this puzzle were scattered across two great intelligence centers, each operating in parallel with incomplete information and no direct awareness of what their counterparts were discovering. In London, deep inside the Admiralty's Operational Intelligence Centre at the Citadel, just north of Piccadilly Circus, a small team of naval officers, civilian analysts, mathematicians, and linguists worked the problem methodically, correlating sighting reports, dead letter box information from agents, and the fragmentary intelligence that reached them through encrypted dispatches. Their American equivalents operated out of the Navy Intelligence Office at the Naval Yard in Washington and from stations scattered across the Atlantic coast, watching the same inexplicable phenomena with growing alarm. Both services possessed access to the ultra-intelligence derived from breaking the Enigma-encrypted radio traffic of the Kriegsmarine, a capability so secret that most officers in active service had no knowledge it existed. Yet the traffic alone could not fully explain what was occurring. The radio messages between U-boats and their command headquarters revealed patrol areas, sinking reports, and fuel status updates, but there were gaps, silences, transmissions that seemed to acknowledge resupply events that had no identifiable source vessel. The conventional wisdom held that a Type ICSI U-boat, Germany's primary ocean-going submarine at the time, could remain at sea for approximately 80 to 90 days. That duration was the product of a mathematical certainty, the volume of fuel oil that could be stored in the boat's tanks, divided by consumption rates at various speeds, minus the fuel required for return voyage to base. Any submarine commander pushing against those limits was accepting proportionally increased risk. The greater the distance traveled, the less margin existed for navigating to safety if discovered. Yet here, in the spring and summer of 1942, U-boats were demonstrating patrol durations that exceeded those calculations by 3 weeks or more. Some boats reported fuel reserves that seemed to have been mysteriously replenished in mid-ocean. Survivor accounts from merchant ships that had been shelled or boarded before sinking occasionally mentioned seeing a second submarine nearby during the attack, a presence that made no strategic sense unless the second boat was performing some function that required a rendezvous at that precise location. The breakthrough came not from a single flash of insight, but from the slow accretion of pattern recognition across thousands of dispersed data points. In the Admiralty's Operational Intelligence Centre, a team led by analysts who spent their days correlating U-boat sighting reports with calendar coordinates began to notice something. If you plotted the locations where merchant ships had been reported sunk and the approximate dates of those sinkings, and then worked backward to estimate where the attacking U-boat must have been a week earlier, you could construct a rough patrol track. When the analysts performed this reconstruction on multiple patrols across several months, certain grid squares in the mid-Atlantic began to appear with unusual frequency. These were not the usual transit routes between the French bases and the distant hunting grounds. Instead, they were locations where U-boats seemed to be lingering, sometimes for days, sometimes for hours, conducting activities that did not fit the profile of hunting merchant ships. The same grid squares recurred in multiple months, suggesting they were not random. The men asking the questions were trained in a particular kind of deduction, the forensic archaeology of naval warfare. They understood fuel consumption rates as intimately as submarine designers. They knew the endurance parameters of every U-boat class that the Germans possessed. They could calculate, almost by intuition, whether a given boat could theoretically have traveled from its last known position to a new position where it had subsequently sunk a ship. When the calculations began to fall short, when the mathematics started suggesting that a boat should not have been able to reach a particular killing ground, the implications became impossible to ignore. Something was happening at those recurring grid squares, something that was extending the operational radius of the U-boat fleet beyond anything that conventional submarine logistics should have permitted. Survivor testimony provided another crucial strand of evidence, though it arrived slowly and piecemeal. Men pulled from lifeboats and later debriefed by naval intelligence officers would mention, sometimes casually, details that seemed trivial until an analyst connected it to other fragments of information. A merchant sailor would report that during the attack, a second submarine had appeared alongside the first, transferring something. The witness could not say what. The chaos of the moment obscured the details, but there had definitely been two boats in proximity. Another survivor remembered seeing what looked like fuel hoses strung between two submarines on the surface. A captain who had watched his ship burn from a lifeboat mentioned the peculiar efficiency of the U-boat that had attacked him. It had not seemed interested in searching for additional targets after completing its attack, as if it had somewhere urgent to be, some appointment that had to be kept. Each detail was individual and somewhat ambiguous, but accumulated together, across dozens of debriefings and dozens of survivors, they began to accumulate into something that resembled a coherent picture. The German radio traffic itself, that carefully encrypted conversation between U-boat command and the submarines at sea, contained hints if you knew how to listen for them. There were transmissions that seemed to order course changes that did not align with known convoy positions. There were acknowledgement messages that suggested rendezvous appointments at coordinates that bore no relation to any identified target. There were occasions when U-boats would go silent for periods longer than their usual radio discipline would account for, and then resume transmission from a location far distant from where their fuel consumption would have logically carried them. The naval intelligence analysts working from the intercept material, reading the German naval orders that came through Ultra, understanding the subtexts and the procedural details embedded in the messages, began to suspect that they were witnessing an entirely new class of vessel, one that did not appear in any of the intelligence summaries about German U-boat production because it was not combat-focused, and therefore had been categorized differently in German naval records. By the autumn of 1942, the evidence had solidified enough for the intelligence chiefs to begin briefing their respective commands. The conclusions they presented were astonishing in their implications. The German Navy, it appeared, had created a dedicated supply submarine, a boat optimized for carrying fuel and provisions rather than torpedoes, designed to meet other submarines at prearranged locations in the mid-Atlantic and transfer supplies to extend their patrol ranges. This vessel represented a kind of elegant solution to the endurance problem that U-boat command had been grappling with since the beginning of the campaign. If you wanted to extend the reach of your wolf packs deeper into American waters, to sustain operations off the Caribbean and the coast of Brazil, you needed submarines that could stay at sea longer. The German Navy had apparently decided that building supply submarines was cheaper and faster than trying to construct bigger combat boats. The intelligence assessment was presented with a mixture of grudging professional admiration and urgent concern. The Germans had moved past the obvious solution and invented a new problem for the Allies to solve. The race was on to find these mysterious supply boats before they could consolidate their advantage. The implications of this discovery rippled through the naval planning structures on both sides of the Atlantic. If the Germans had indeed created a dedicated supply submarine capability, then the entire nature of the U-boat threat had shifted. The reach of the wolf packs would be theoretically unlimited. The only constraint would be the number of supply boats available and their ability to operate undetected. Conversely, if the Allies could locate and destroy these supply submarines, they would be cutting a lifeline that the Germans appeared to have built their entire expanded strategy upon. The ocean became, in the minds of the intelligence analysts and the operational commanders who received their reports, a different kind of chessboard. The grid squares where the supply boats met with their hungry combat flotillas became priority targets. Every available intelligence asset, the ultra-decryption teams, the human intelligence networks operating out of neutral Portugal and other listening posts, the direction-finding teams that could triangulate U-boat radio transmissions, was refocused with new urgency on finding the supply submarine network. But finding a submarine in the ocean is a problem that admits of no easy solution. The Atlantic covers roughly 80 million square kilometers. A submarine is tiny, invisible, silent. You cannot simply patrol the ocean looking for a particular vessel without knowing where to look. You must work from intelligence, the radio transmissions that betray position, the patterns in sinking reports that suggest supply locations, the fragmentary human intelligence that occasionally provides a name or a designation. The Allies had some of these tools, but they remained incomplete. The ultra-intelligence was invaluable, but it required time to intercept, decrypt, and analyze, and by the time a message had been broken and its contents understood, the submarine mentioned in that message might have already left the area. The direction-finding teams could locate a transmitting U-boat if it broadcast on the right frequencies, but the German Navy was learning to minimize transmissions, to use brief, heavily encrypted bursts that made triangulation difficult. The human intelligence was sporadic and sometimes misleading, rumors from source networks that proved false, speculative assessments based on incomplete information. What the Allies possessed, however, was organization, persistence, and a growing understanding of how the supply submarine network actually functioned. The intelligence services began to compile a catalogue of the clues. They estimated that the Germans probably operated somewhere between 6 and 10 dedicated supply boats, based on the frequency of resupply events they could identify and the likely capacity of such vessels. They began to develop profiles of the U-boat captains who seemed most frequently involved in resupply rendezvous, the most aggressive hunters, the ones operating furthest from home, the ones who consistently seemed able to sustain patrols longer than physics should have allowed. They drew up estimates of fuel consumption and transfer rates, calculations that allowed them to predict where and when future supply meetings might occur. They began to understand the radio procedures and the coded language that the Germans used to coordinate these rendezvous points. The intelligence machine, once it understood the problem, began to churn with purposeful efficiency. By late 1942 and into the spring of 1943, the hunt for the milk cows had become one of the highest priority tasks in the entire Allied naval war effort. The intelligence services had provided the pieces of the puzzle to the operational commanders, the estimate that such vessels existed, the probable areas where they operated, the understanding that they were vulnerable because they had to surface to perform their supply function. Now it fell to the navies themselves to translate that intelligence into action. The question that had been asked in the intelligence centers, how are German submarines operating so far beyond their calculated range, had been answered. The next question, the one that would determine the outcome of the Battle of the Atlantic, was whether the Allies could locate and destroy these mysterious supply boats before the war at sea turned irrevocably in Germany's favor. The hunters were closing in, but the prey did not yet know it was being hunted, and the race was far from decided. In the spring of 1942, as the first Type 14 milk cows were beginning their operational patrols, the Allied intelligence machine was still searching for answers to an impossible problem. U-boats were sinking ships in waters where, according to every calculation the Admiralty and the United States Navy possessed, they should not be able to reach. Merchant vessels were being sent to the bottom off the American coast, in the Caribbean, and in the Central Atlantic, places where U-boat commanders, if operating from French bases and adhering to theoretical range limits, should have exhausted their fuel supplies long before arriving. The pattern was wrong. The mathematics did not align. Something was sustaining these submarines far beyond their anticipated endurance, and the intelligence officers, tasked with understanding the enemy, were running against a wall of ignorance that threatened to become fatal. The breaking of the German naval Enigma machines had given the Allies an extraordinary advantage, one that was not fully appreciated even by some of those who wielded it. Since early 1941, cryptanalysts working in the closely guarded compound at Bletchley Park in England had been solving the daily settings of the Kriegsmarine's principal cipher, a process that required not only mathematical brilliance, but also an understanding of German naval procedures, weather patterns, and the rhythms of U-boat operations themselves. The information extracted from these broken messages was collated into a steady stream of intelligence about U-boat positions, patrol areas, refueling schedules, and operational orders. This intelligence, codenamed Ultra in the highest circles, was so sensitive that its existence was restricted to only a handful of commanders in the Royal Navy and the United States Navy, and sharing even fragments of it with frontline units risked revealing to the Germans that their cipher was compromised. Yet the intelligence officers who read these decrypts began to notice something peculiar in the message traffic. U-boats were reporting to their headquarters in France and Germany that they were proceeding to rendezvous points in the middle of the Atlantic, grid squares that corresponded to open water, far from any known port or resource. The messages were sparse, cautiously worded, but they revealed the ghost of a logistical system that should not exist. The second avenue of intelligence was older, more mechanical, and in many respects more immediate. High-frequency direction finding, a technique known in the Allied navies as huff-duff, worked on a principle so straightforward that it had almost been overlooked in the early war years. When a submarine transmitted a radio message, the electromagnetic waves it sent out could be detected and measured by multiple receiving stations scattered across the Atlantic. The signals traveled at the speed of light, and by measuring the precise moment at which a transmission arrived at different stations, skilled operators could calculate the position of the transmitter with remarkable accuracy. A single huff-duff bearing gave a line of position, nothing more. But two bearings, taken from widely separated stations, could be crossed to narrow the location to a relatively small geographic area. 3 or more bearings could pinpoint a target with confidence. The German U-boat command believed, or had convinced itself to believe, that their radio transmissions could not be tracked, that huff-duff was a technique of limited value, or that the Allies had not developed it sufficiently to pose a real threat. This belief, maintained through repeated warnings from thoughtful officers in the Kriegsmarine that radio security was being undermined, would prove to be one of the most consequential delusions of the war at sea. By the middle of 1942, the pieces were coming together in the minds of the intelligence officers who had access to both ultra-decrypts and huff-duff bearings. The hidden supply boats began to emerge from the blur of data, like submarines themselves, rising through murky water. A U-boat would radio a message indicating that it was proceeding to a rendezvous, and simultaneously, or shortly thereafter, a different U-boat, operating far from any known German base, in a position that made no tactical sense if it were acting alone, would be detected by huff-duff in an area that aligned precisely with where the first message had indicated the rendezvous would occur. The pattern repeated. The supplies were being transferred somewhere in the open Atlantic, in locations that were deliberately chosen to be far from Allied patrol areas, in waters where the risk of discovery had, in theory, been minimized by careful planning. But the transmissions themselves had become a beacon. Every radio message sent by a supply boat to announce its position, to confirm its readiness for a transfer, or to communicate with distant U-boat command, was a pulse of energy, broadcasting the location of a vessel that could not move quickly, that could not dive and hide, while engaged in the delicate work of transferring fuel and stores to another submarine. The milk cows had become, in effect, light bulbs in the darkness. The intelligence picture sharpened through the autumn and winter of 1942 and into the spring of 1943. The Operational Intelligence Centre at the Admiralty in London, staffed by naval officers, mathematicians, and language specialists who understood the U-boat service from both technical and human perspectives, began to produce assessments that went beyond confirming that supply vessels existed. They began to identify patterns in where the rendezvous operations were taking place, the approximate number of supply submarines in operation, and the times when new supply runs were being planned. The American equivalent, the Naval Code-Breaking Center at the Navy Department in Washington, was conducting parallel analysis, and the two intelligence services, having learned to work together despite the barriers of national interest and institutional friction, began to share increasingly specific information. The supply boats, the analysis suggested, were Type 14 submarines. a special variant that the intelligence services had identified in the captured German technical documentation and in the photographs taken during raids on German ports and shipyards. There were at least 10 of them, possibly more. They were being built at specific yards, and they were beginning to enter service at regular intervals. This was not a desperation measure by a desperate enemy. This was a conscious, sustained, and genuinely innovative response to the problem of range limitation in submarine warfare. With intelligence came opportunity, and with opportunity came the question of how to kill these vessels before they could be multiplied. The Type 14 boats had been identified, tracked through radio intercepts, and in several cases partially located by Huff-Duff bearings that gave a general sense of their operating areas. But turning intelligence into action required different tools and different chains of command. The Admiralty in London and the Navy Department in Washington began the process of retasking their available resources, the precious few escort carrier groups that were available in the mid-Atlantic, the long-range patrol aircraft that could be diverted from other duties, and the surface escort vessels that could be coordinated into hunter-killer groups operating at extended range. The focus of the anti-U-boat campaign, which had been aimed broadly at disrupting the Wolfpack attacks on convoys, began to narrow. A specific hunt was being organized. The milk cows were to be eliminated. The task was more complex than simply knowing where a supply boat was, or approximately where it was going to be. A Huff-Duff bearing gave a line of position measured in kilometers, and the Atlantic was vast. A single transmission detected by 2 shore stations could narrow the location to a band of ocean hundreds of kilometers long and perhaps 50 to 100 kilometers wide. Finding a submarine in that area, even with dedicated aircraft and surface ships, was a problem of coordination, timing, and luck. But the intelligence officers understood something that was crucial. The rendezvous operations themselves created a window of vulnerability that could be exploited. 2 submarines meeting in the open Atlantic had to surface, or nearly surface. They had to conduct their business slowly, carefully, in the dark if possible, but not always successfully. The process could take several hours. During that time, they could not move with any speed. They could not maneuver to evade an attacking aircraft. They could not dive and disappear, because the moment they did, the transfer would be abandoned and fuel would be lost. If an Allied aircraft or warship could be positioned in the right place at the right time, the mathematics of the problem would shift dramatically in the Allies' favor. The escort carrier groups that were being retasked specifically for this anti-Milch Cow mission represented the cutting edge of Allied naval innovation. These were small carriers, faster and more maneuverable than the fleet carriers, but less heavily armed. They carried roughly 20 to 30 aircraft, a mixture of fighter aircraft for protection against German patrol planes and torpedo bombers, and anti-submarine aircraft equipped with radar, depth charges, and increasingly sophisticated acoustic detection equipment. The escort carriers operated best in the mid-Atlantic, that region that had been beyond the range of land-based aircraft throughout the early years of the war, and which had served as a relative sanctuary for U-boats and their supply vessels. Now, that sanctuary was being invaded. A single escort carrier, supported by a screen of destroyer escorts and corvettes, could place an aircraft into the air within minutes of receiving intelligence that a rendezvous was about to occur or was occurring in a specific grid square. The aircraft could remain aloft for several hours, searching with radar that could penetrate darkness and clouds. If a submarine was found, a trained anti-submarine crew could attack with depth charges, or, in the newest variants, with acoustic homing torpedoes that did not require the aircraft to remain overhead, but could be dropped and left to hunt their target through the water. The first confirmed kills began to come in the late spring of 1943, as the operational tempo of the anti-submarine campaign intensified. A Type 14 boat would be detected by Huff-Duff as it transmitted position information to coordinate a rendezvous. The bearing would be passed immediately to the escort carrier groups operating in that region. Aircraft would be launched. The race would begin to locate the submarine before it completed its transfer and submerged. or to catch it just as it was beginning to move away from the rendezvous point. Sometimes the aircraft arrived to find an empty sea, the boats having completed their business and parted ways, or having detected the transmissions of the searching aircraft and decided to abort the operation. But sometimes, the timing aligned perfectly. An aircraft would emerge from the clouds or the darkness to find two submarines on the surface, their hulls casting hard shadows under the beam of an aircraft searchlight, the transfer hoses visible between them, the crews unable to do anything but watch as death approached from the sky at an altitude of mere hundreds of feet. The speed of destruction in those moments was almost incomprehensible. A few seconds of machine gun fire, the impact of depth charges dropped from an aircraft fuselage, and a boat that had been built over months and crewed by men who had trained for years was reduced to spreading wreckage and oil slick disappearing beneath the Atlantic. The Germans, in U-boat command headquarters in Paris and Berlin, began to receive reports that the supply boats were missing. A milk cow that had been scheduled to make a rendezvous simply never transmitted on the expected frequency. Another boat, which had been in regular radio contact with U-boat command, suddenly ceased transmitting in mid-patrol. The circumstances were strange. There were no reports of Allied warships engaging the supply submarines. There were no survivor accounts, no radio distress calls, no evidence other than the silence itself. Admiral Dönitz and his staff, who had invested considerable resources and intellectual capital in the Milk Cow program, were forced to confront a problem that was qualitatively different from simple attrition. It was not that the supply boats were being damaged or lightly attacked and forced to return to port. It was that they were being systematically found and destroyed, and they were being found with enough frequency and in enough different locations that it could not be mere coincidence. Something in the system had been compromised. The question was what, and the answer would reshape the war at sea. The core vulnerability of the Milk Cow program lay in a paradox that was almost impossible to resolve. The supply submarines had been designed to extend the range of the U-boat campaign, to enable the wolf packs to operate in areas far from any supporting infrastructure. This extension of range required coordination, and coordination required communication. A milk cow and a combat U-boat could not meet at a random point in an empty ocean. They had to know where to find each other, and that knowledge had to be transmitted via radio across vast distances from command headquarters that were fixed on shore. Every radio message was a transmission that could be detected, measured, and triangulated. The higher the frequency of communication, and as the campaign intensified and more boats needed resupply, the frequency had to increase, the greater the risk of detection. The Germans attempted to solve this problem by changing frequencies, by using short, cryptic messages, and by designating specific times and specific grid squares for rendezvous operations, in the hope that the randomness of the arrangement would make the system harder to penetrate. But the Allies had broken the Enigma machine. They knew the frequency schedule, and more importantly, they knew approximately when and where rendezvous were being planned, even before the messages were sent. Ultra-intelligence was guiding the hunters to their prey with an accuracy that bordered on supernatural. The collapse of the Milk Cow system as a supply mechanism was not sudden, not a single catastrophe that could be pointed to as a moment of failure. It was instead a grinding attrition, a slow hemorrhage of capacity, as individual boats were sunk, as the confidence in the system eroded, and as Dönitz was forced to acknowledge that the elegant logistics network he had constructed had been turned by the enemy into a trap. The supply boats had been designed as the servants of the U-boat campaign, the means by which the tonnage war could be sustained and expanded. Instead, they had become the focus of the Allies' deadliest intentions, and by attempting to save the U-boats, they had marked themselves for destruction. The intelligence war, ultra-decrypts, Huff-Duff bearings, radio direction finding, and the coordination of that intelligence with air and sea assets had transformed the strategic equation. The Germans had believed they possessed a technology that would revolutionize submarine warfare. The Allies had responded with the only technology that truly mattered: the ability to know where the enemy was, and the willingness to concentrate overwhelming force against a single, identified target. It was in this crucible of signals intelligence and coordinated violence that the Milk Cow Age began its rapid descent toward extinction. In the spring of 1942, the Atlantic Ocean still belonged to the submarines. The vast expanse between North America and Europe, the gap that stretched roughly 750 kilometers beyond the range of any land-based patrol aircraft, had become a sanctuary for the U-boat fleet. Here, in the middle distance, where neither the long-range liberators flying from Newfoundland nor the Hudsons operating from Iceland could reach, German submarines hunted with relative impunity. It was in this emptiness that the milk cows were born to do their work, and it was in this same emptiness that they would face their reckoning. But in 1943, the geography of the Atlantic began to shrink. The Allies understood that the mid-Atlantic gap was a wound in their defenses, and they were determined to close it. The weapon they chose was small, unassuming, and entirely unfamiliar to the men who would face it. The escort carrier would change everything. The escort carrier was not a warship of majesty or convention. Built on converted merchant hulls and designed in haste, these small carriers displaced perhaps 14,000 tons, smaller than many heavy cruisers, with a single flight deck that seemed almost improvised against their narrower beams. The Americans called their version the Casablanca class, and they would eventually build 50 of them. The British built the Attacker class and other variants. These were not the mighty fleet carriers that shaped the naval imagination. They were workmanlike, utilitarian vessels, stripped to their essence. Yet within their compressed hulls lay a revolutionary idea that air power could be brought to the hunter-killer team, that a small group of ships, a carrier, a handful of destroyers and frigates, could become a self-contained anti-submarine force, capable of searching thousands of square kilometers of open ocean. The escort carrier was the embodiment of that concept made steel and motion. What made the escort carrier revolutionary was not any single innovation, but the combination of technologies and tactics that gathered around it. Each carrier typically launched roughly 20 aircraft, a mix of torpedo bombers and fighters, though in the anti-submarine role, the distinction mattered less than it might have in battles for control of the skies. The aircraft were fitted with radar, a technology that the U-boats did not yet fully appreciate as a threat at sea. Radar allowed these planes to search for submarines at night and in cloud, to sweep vast areas with mechanical efficiency that human eyes could never match. The escort carrier groups also carried sonobuoys, sensitive acoustic listening devices that could be dropped from aircraft to listen for the underwater sound of a submarine's machinery. When a sonobuoy picked up the distinctive acoustic signature of a diesel engine, that particular rhythmic pulse that every U-boat commander would come to dread, the aircraft could guide destroyers and frigates to the exact location. This was not guesswork or luck. This was precision. The escort carriers did not operate alone or at random. They were the centerpiece of a coordinated system that had been built inside the Allied command structure with methodical purpose. The key was intelligence. Messages intercepted and decoded through the cryptanalytic breakthrough of Ultra, the reading of German naval Enigma traffic, told Allied commanders where supply rendezvous points would occur, when milk cows would be waiting in particular grid squares, and where the combat submarines would attempt to meet them. Once that intelligence was transformed into a heading and a distance, the escort carrier groups were directed to the location. They would arrive with weeks of supplies and fuel, ready to conduct operations in a defined area. When a U-boat attempted its surface transfer, or when a milk cow transmitted the radio signal to arrange a rendezvous, the escort carrier group would be waiting. The hunters and the hunted would meet not by chance but by design. The tactical innovation extended beyond mere presence. The escort carrier groups operated with a doctrine that had been refined through bitter experience in the Atlantic. When a contact was made, the response was coordinated and overwhelming. Aircraft would be launched immediately to maintain contact and harry the submarine, keeping it from diving, driving it deeper, exhausting its battery power. Surface escorts would converge on the location, using their own sonar to prosecute the attack. The carrier group had learned that patience was worthless. The optimal response to a submarine contact was maximum violence, sustained until the target was destroyed. This was not the sort of warfare that the traditional submarine service had prepared its crews to face. The U-boat had been built for stealth and for the deadly efficiency of the torpedo attack on the surface, where the submarine remained vulnerable but mobile. Against an enemy that could see you from the air, that could shower depth charges from above and alongside, that had patience and numbers and scientific instruments that worked even when you were submerged, the old tactics were becoming obsolete. The first indication that something fundamental had changed came quietly, through the simple absence of expected signals. A milk cow would depart from the French bases on patrol, would proceed to the open Atlantic, would transmit its initial position reports to U-boat headquarters at Lorient, according to the established schedule. Then, at the prearranged time and place, it would go silent. The rendezvous would not occur. The combat submarines waiting in their assigned grid square would begin transmitting urgent inquiries. U-boat command would receive growing reports of confusion and cancellation. Days would pass, and no message would arrive from the supply boat. Eventually, the conclusion would be unavoidable. The boat was gone, sunk without warning, without explanation. Its crew of 50 men had simply ceased to exist in the moment they were needed most. The shock within U-boat command was profound and sharply different from the standard casualties of the Atlantic campaign. The loss of a combat submarine was regrettable, but accepted as an occupational hazard. These boats went out to sink ships, and in the course of that work, some would themselves be sunk. That was the nature of the war at sea, but the milk cows had no such justification. They carried no weapons, made no offensive contribution. They existed solely to serve the fleet, to extend its reach and duration. Their destruction accomplished nothing for Germany, except damage. And they were dying with the speed and thoroughness of boats that had been specifically hunted. In June of 1943, the milk cow designated U-118 perished in a coordinated attack by aircraft and surface escorts, the first loss of a Type 14 that Allied forces could confidently claim. It was followed rapidly by others. The pattern became impossible to ignore. The milk cows were being found and destroyed in their operating areas with a precision that suggested not accident but design, not luck but intelligence. Admiral Dönitz received the reports with growing alarm. His entire strategic reconstruction of the U-boat campaign depended on the survival and effectiveness of the supply submarines. Without them, the extension of patrol ranges that had seemed so elegant on paper became impossible to sustain. The U-boats that depended on rendezvous with milk cows would have to either proceed to their assigned operational areas without adequate supplies, a course that shortened their effective patrol duration, or attempt dangerous alternative arrangements with improvised supply vessels. The Allies, by destroying the milk cows, were not simply eliminating logistics vessels. They were unraveling the entire mathematical foundation that Dönitz had constructed. The Admiral issued orders for increased security measures, changes to radio procedures, alteration of rendezvous coordinates. These orders were technically sound, the work of a commander acting with full awareness of the threat, but they were also largely ineffective. The fundamental problem was not a breakdown in German procedures or a gap in security consciousness. The fundamental problem was that the Allies possessed a source of information so complete and so current that they could follow German movements in near real time. The milk cow captains and their crews did not understand this. They made changes, they hoped. They tried every tactic they knew, and the escort carrier groups continued to find them. What the escort carriers had accomplished was not merely the destruction of individual supply submarines, though that was consequential enough. They had shifted the entire balance of vulnerability in the Atlantic. Previously, the surface conditions that the milk cows required for transfer operations, calm seas, low visibility if possible, time to complete the diesel transfer without haste, had also been conditions of relative safety. The submarines could rely on darkness and on the simple vastness of the ocean to provide protection. Detection was never certain, and the long passage from France to the mid-Atlantic was achievable if a boat remained careful. But the introduction of the escort carrier changed this equation. Now a milk cow proceeding to its operating area was not merely trying to avoid casual detection by a passing merchant convoy or a randomly deployed warship. It was potentially moving toward a hunter-killer group that was vectored to intercept, that possessed technological advantages in detection and weaponry, and that had days or weeks of supplies and fuel to conduct a methodical search. The advantages that had once belonged to the submarine, concealment, surprise, knowledge of location, had been neutralized. The airdropped sonobuoy and the radar-equipped aircraft had made the ocean smaller and more dangerous. The specific loss of the Milk Cow, designated U-462 in July of 1943, exemplified the new tactical reality. The boat had been proceeding to its assigned operational area when it was detected by an escort carrier group. It attempted to evade, it maneuvered, it tried to break contact and submerge. But the escort carrier's aircraft maintained contact using radar, their sonobuoys tracking the submarine's underwater movement through the sound of its motors. Surface ships converged on the position provided by the aircraft. The Milk Cow was forced deeper, its batteries draining with each passing hour, its crew enduring the psychological torture of knowing that they were being hunted with technological precision, that evasion was nearly impossible. When the depth charges began falling, the outcome was never in doubt. The boat was destroyed with all hands. Within U-boat command, the reports of such losses created a growing sense of helplessness. The supply submarines were being systematically eliminated, and the methods being used to eliminate them suggested capabilities that the Germans had not anticipated. The psychological impact of these losses reverberated through the U-boat service with particular intensity, precisely because the milk cows occupied an unusual position within the fleet. Combat submarine crews accepted losses as part of their profession. They understood that their boats went out to make war, and that in making war, losses were inevitable. The crews of the milk cows, by contrast, had enlisted in a support role. They had volunteered or been assigned to maintain the supply chain, to feed and fuel the hunters, not to be hunters themselves. These men were disproportionately mechanics, engineering specialists, medical personnel, trained for logistical support rather than combat. When such men died in large numbers, when boats that carried no weapons and posed no offensive threat were being hunted down with apparent ease, the moral calculus began to shift. The men aboard the remaining milk cows understood, with a clarity that no official briefing could have provided, that they had become expendable in a game they had not fully understood they were playing. The arrival of the escort carrier groups marked the true end of the era that the milk cows had created. In 1942, the supply submarines had seemed like a solution to a fundamental problem: the extension of U-boat range and endurance in the face of Allied convoy defenses. For a brief period, they had succeeded magnificently, but that success had been built on assumptions about the security of the mid-Atlantic, assumptions that had proven tragically optimistic. The Allies had responded to the milk cow network not with a single counterweapon, but with a systematic and coordinated approach that brought together intelligence, technology, and tactics into a unified whole. The escort carrier was the capstone of that response. By the autumn of 1943, the first phase of the milk cow campaign was effectively over. The boats that should have been feeding the fleet had become casualties themselves, sunk faster than they could be replaced, their sacrifice rendering the entire logistical enterprise increasingly desperate and ineffective. The hunters and the hunted had changed places, and the mathematics of the Atlantic War had shifted once more against Germany. By the spring of 1943, the Type 14 milk cows had become indispensable to the U-boat campaign. They were the invisible infrastructure that allowed Dönitz to sustain his wolf packs across the vastness of the Atlantic. Yet the very success of the milk cow concept contained within it the seeds of catastrophe. The supply boats had to surface regularly, had to remain in fixed positions long enough to transfer fuel and provisions, and most critically, they had to transmit radio signals to coordinate rendezvous appointments with the combat U-boats that depended on them. Each transmission was a beacon. Each beacon could be detected. Each detection could be plotted, triangulated, and turned into a death sentence. The Allies had broken the naval Enigma cipher months earlier. High-frequency direction-finding equipment, the so-called Huff-Duff apparatus, could fix the position of any radio transmission within kilometers. When a Milch Cow radioed coordinates to a waiting pack of combat submarines, it was essentially broadcasting its own execution order to a listening Allied intelligence apparatus that had learned to read every word. The attrition began quietly, without warning, in a way that suggested something had shifted fundamentally in the balance of the Atlantic War. In the first weeks of May 1943, U-boat command's communication logs began recording gaps where they should not have been. A Milch Cow scheduled to rendezvous with a combat boat in a designated grid square simply never arrived. The combat boat waited, transmitted requests for position updates, received only silence. Then another silence followed another. Within days, the pattern became unmistakable. Something was hunting the supply submarines with methodical precision. Admiral Dönitz, sitting in his underground headquarters at Lorient, in occupied France, watched his carefully constructed logistics network begin to unravel before his eyes, and he could not understand how or why. The Germans had no way of knowing that Allied convoy escorts had been withdrawn from the North Atlantic and redeployed specifically to hunt milch cows. They did not know that every Enigma message they sent was being read by the Admiralty within hours. They did not know that escort carrier groups armed with long-range aircraft and acoustic detection equipment were being vectored directly toward the grid coordinates where their supply submarines were supposed to be. The first confirmed loss came in May, when a Type 14 was caught surfaced during a transfer operation by Allied aircraft. The Milch Cow attempted to dive, but the transfer hoses were still connected to the combat boat alongside it. The supply submarine had to choose between abandoning the transfer and remaining vulnerable on the surface to help its partner boat escape. The crew chose duty over survival. The boat was raked with depth charges and sunk with all hands. The news of this loss, when it filtered through U-boat command channels, was absorbed with grim acceptance. Losses happened. Boats were sunk. That was the nature of submarine warfare. What neither Dönitz nor anyone in his command structure fully grasped yet was that this was not the random attrition of operational warfare. This was systematic, coordinated, and accelerating. The Allies were not searching blindly across the Atlantic, hoping to stumble upon a supply submarine. They were reading the rendezvous coordinates from German radio traffic, calculating the likely location of the meeting point, and dispatching hunter-killer groups to intercept the boats before they could complete their transfer and scatter. The mathematics of the situation was ruthlessly simple and entirely favored the side with the better intelligence. By mid-May, the pace of losses accelerated sharply. A second Type 14 was caught by an escort carrier's aircraft in the central Atlantic. The Milch Cow's commander attempted an emergency dive, but the boat was heavily laden with fuel and provisions, riding low in the water, sluggish in its descent. The aircraft released its weapons before the submarine could reach sufficient depth. The boat exploded, taking its crew down, with a cargo hold still full of supplies that would never feed hungry submariners. A third Milch Cow, attempting to alter its rendezvous pattern to evade what its captain suspected was increasing Allied activity, changed its radio frequency and shifted its meeting coordinates. The Allies, reading the new Enigma keys almost as quickly as they were transmitted, simply adjusted their intercept point. When the boat surfaced for its rendezvous, Allied ships were waiting. The battle was brief and entirely one-sided. The Milch Cow had no weapons to speak of, no torpedo tubes ready to mount a defense, no capacity for combat. It was a supply vessel caught in the open ocean by the hunters it could not escape. The crew fought with whatever makeshift weapons they could improvise on deck, but the outcome was never in doubt. The boat went under, and another intelligence link in the German supply network was severed. Desperation began creeping into the communications between Dönitz's headquarters and the surviving Milch Cow commanders. The admiral issued orders to change radio frequencies constantly, to reduce the duration and frequency of transmissions, to use prearranged signals that required fewer words and thus less time on the air. Every second a radio operator spent broadcasting was a second in which an Allied Huff-Duff operator was plotting a bearing, narrowing down the position, calculating approach vectors. Dönitz ordered his supply boat captains to go silent for extended periods, to rely on dead reckoning and rendezvous protocols that had been established weeks in advance, to minimize the radio traffic that had become their greatest vulnerability. Yet the orders themselves had to be transmitted, which meant more radio traffic, which meant more opportunities for the Allies to detect, locate, and attack. The system had entered a vicious cycle. The more pressure placed on the Milch Cows to keep the U-boat campaign alive, the more transmissions they had to make, and the more vulnerable they became. The elegant logistics solution that had seemed so brilliant in 1942 was revealing itself as a strategic trap. A fourth Milch Cow was sunk in late May when it was caught by a surface escort vessel that had been specifically vectored to its position based on radio direction finding from multiple stations. The boat attempted to run on the surface, racing to shallow water where it might escape or find shelter. The escort vessel closed the distance with remorseless efficiency. When it became clear that the Milch Cow would not escape, the captain gave the order to scuttle. The boat went down under controlled conditions, its crew taking to the water, some rescued by the very escort vessel that had hunted them, pulled from the Atlantic and taken into captivity. The loss of 4 Type 14 boats in a matter of weeks had a cascading effect on the U-boat campaign. Combat boats that were supposed to rendezvous with specific Milch Cows found only empty ocean. Their fuel was running low. They had to make critical decisions, continue their patrol, and risk running out of diesel fuel far from home, or abort the mission and return to base, wasting weeks of voyage and precious resources. Many chose to return. The patrol densities that Dönitz had relied upon to overwhelm Allied convoy defenses began to collapse, not because the combat boats had been sunk, but because they could not stay at sea long enough to reach the hunting grounds. The senior officers at U-boat command began to understand, perhaps for the first time, the true vulnerability of their supply system. The Milch Cows had been conceived as an elegant solution to an operational problem, but they had also created a catastrophic dependency. The entire U-boat campaign now rested on the survival of a handful of vulnerable supply submarines that could not fight, could not flee effectively, and could not remain hidden because they had to surface to do their work. When one Milch Cow was sunk, it did not simply remove a logistics asset from the equation. It removed the patrol capacity of every combat boat that had been scheduled to receive supplies from that vessel. It cascaded through the entire system like a falling domino that knocked down a dozen others in its wake. And worse, the Allies seemed to know exactly where and when the supply submarines would be. The question haunted Dönitz and his staff. How were the Allies finding them with such appalling accuracy? The possibility that the Enigma itself had been compromised was considered, and then rejected. The cipher had been considered unbreakable. It had to be unbreakable. To accept that it had been broken was to accept that the entire apparatus of German naval communication was transparent to the enemy. Through May and into June, the losses continued. A 5th Type 14 was caught attempting to deliver supplies to a wolf pack that was itself being hunted by an escort carrier group. The Milch Cow's captain had no way of knowing that his rendezvous coordinates had been compromised, that the combat boats he was supposed to meet had already suffered losses and were dispersing. When the supply submarine surfaced, it found not friendly U-boats but enemy escorts. The captain fought a brief, hopeless battle and then ordered the boat abandoned. A 6th Milch Cow, attempting to find shelter in the remote southern Atlantic, was intercepted by a hunter-killer group that had been searching for it for nearly 3 weeks. The crew had suspected they were being hunted. Every experienced sailor knew the feel of being pursued, a kind of pressure in the air that no instrument could measure, but that every experienced naval officer could sense. They had altered course multiple times, tried to hide in areas where they thought Allied aircraft were less likely to search, maintained radio silence despite the desperate need to coordinate with the combat boats that required their supplies. None of it mattered. The Allies found them anyway, because they already knew where to look. Dönitz's orders became increasingly frantic, increasingly desperate. He ordered the surviving milk cows to operate in new areas, to abandon the central Atlantic rendezvous points and establish supply lines in more remote parts of the ocean, where he believed Allied patrols were thinner. This was a concession of enormous strategic significance. The central Atlantic rendezvous points had been carefully chosen because they were roughly equidistant from the American and British coasts, allowing combat U-boats to reach operations areas off both North America and Britain with the same patrol duration. Moving to more remote locations meant that the combat boats had to spend more time transiting and less time fighting, which meant fewer sinkings, which meant the entire tonnage war strategy began collapsing piece by piece. The admiral was essentially accepting defeat in the Atlantic by degrees, moving his supply network away from the crucial operational areas, conceding the center of the ocean to the Allies in a desperate attempt to protect the handful of supply submarines he had left. By July, 7 of the 10 Type 14 boats had been sunk or were presumed lost. The German logistics machine that had seemed so formidable just months earlier was functionally extinct. The final surviving milk cows operated in a state of profound isolation through the autumn of 1943. They maintained radio silence for extended periods, attempting to minimize their electromagnetic signature, yet this very silence made coordination with the combat boats nearly impossible. Combat U-boats that were supposed to rendezvous at a specific grid coordinate on a specific date would arrive to find empty ocean and no way to contact the supply submarine to determine whether it was running late or had been sunk. The tension aboard these boats must have been extraordinary, fuel running low, provisions dwindling, aware that the milk cow that was supposed to sustain them had not appeared and would likely never appear. The entire architecture of extended-range operations that Dönitz had built with such care was collapsing into chaos and silence. The supply submarines that survived the initial onslaught of Allied attacks found themselves not merely hunted, but abandoned by a command structure that had come to regard them as liabilities rather than assets, abandoned by the combat boats that could not wait for them and had to make their way home on whatever fuel remained. The psychological burden on the crews of these surviving vessels must have been immense. They were still attempting to do their job, still trying to supply the boats that desperately needed them, yet they knew with increasing certainty that the system had failed, that their survival served no strategic purpose, that they were ghosts continuing to operate in a network that no longer functioned. By the autumn of 1943, the era of the Type 14 milk cow had effectively ended. The boats still existed, a few of them would continue to survive for months or even years, but they had lost the capacity to affect the outcome of the Atlantic War. The U-boat campaign itself had already been broken. This would come to be known as Black May, when more submarines were lost than Allied ships sunk, when the mathematics that Dönitz had constructed so carefully finally ceased to work in Germany's favor. The destruction of the milk cow network had not caused this collapse by itself, but it had been a critical enabling factor. Without reliable supply boats, the combat U-boats could not sustain the patrol densities needed to overwhelm convoys. Without patrol densities, the wolf-pack tactics that were the foundation of the tonnage war strategy became impossibly ineffective. Without a functioning supply system, the Atlantic simply became too vast, too dangerous, and too heavily defended for Germany's submarines to dominate it any longer. The Allies, reading every German radio transmission, understanding the rendezvous coordinates and supply routes, had systematically dismantled the logistics apparatus that made the extended U-boat campaign possible. and in doing so, they had delivered the decisive blow not against the submarines themselves, but against the system that sustained them. By the spring of 1943, Admiral Karl Dönitz faced a mathematics that no longer worked. The Type 14 submarines, the purpose-built milk cows that were supposed to sustain his wolf packs indefinitely, were being hunted down faster than the dockyards could replace them. Each sinking meant not just the loss of a vessel, but the loss of a carefully trained crew, a bespoke logistics platform, and most critically, the loss of fuel and supplies that were now sitting at the bottom of the Atlantic instead of flowing to the combat boats. The elegant system Dönitz had envisioned, a web of supply rendezvous points stretching across the mid-ocean, fed by dedicated logistics submarines, was unraveling in real time. And yet the U-boat campaign itself could not pause while new milk cows were being constructed. The combat boats still needed to hunt, the wolf pack still needed to be fed. So Dönitz, the man who had thought through every calculation, made a decision that revealed the desperation beneath his strategic vision. He would convert the combat submarines themselves into supply vessels. The order came down from U-boat headquarters in the spring of 1943. Standard Type IXC and Type 9D boats, the same submarines that had been hunting merchant vessels in the Atlantic, the same classes that had achieved sinkings in the thousands of tons, would be stripped of their offensive capability and refitted as improvised supply submarines. The reasoning was brutal in its simplicity. A combat boat with no combat boats to supply is merely a vessel consuming resources. A combat boat converted to carry extra fuel and stores becomes, in that moment, more valuable to the campaign than its own firepower. The boats selected for conversion were the ones that had already completed several patrols, worn and tired hulls that no longer had the tactical edge their younger counterparts still possessed. They would be brought to the repair yards in the French Atlantic ports, Saint-Nazaire, Lorient, La Pallice, and there, piece by piece, they would be unmade as weapons and remade as logistics nodes. The conversion process was not an elegant undertaking. The Type WinXC and Type 9D hulls had been engineered around a central purpose, to carry a crew of around 50 men and enough torpedoes to wage war across ocean distances. The forward torpedo room that had held 4 to 6 expensive and lethal weapons now held nothing but improvised fuel bladders, essentially reinforced canvas bags that could hold diesel oil squeezed into every available cubic centimeter of space. The deck guns and anti-aircraft armament that had given U-boats at least a theoretical chance against surface threats were removed entirely, leaving the boat exposed and defenseless. The galley and crew spaces that had been cramped before were now suffocating, squeezed even tighter by the addition of supplies, spare parts, medical provisions, and the hoses and equipment necessary to transfer fuel and torpedoes to other boats. Where a combat boat had carried perhaps 2 or 3 spare torpedoes, an improvised supply boat would attempt to carry 4 or 5, lashed down in the interior spaces and ready to be passed across to a waiting combat vessel. The conversion was a form of cannibalization. The submarine was still a submarine, but the engineering that had made it a hunter was now buried beneath the weight of logistics. The crews selected for these converted boats faced a peculiar and disheartening adjustment. The men who climbed aboard a Type IXC that had been designated for conversion were submarine officers and sailors who had trained to sink ships, who understood themselves as warriors in a weapon system that represented the cutting edge of German military innovation. Now they were being asked to see their boat differently, not as a hunter, but as prey that could be hunted, a slow, lumbering supply platform without the firepower to defend itself. The psychological cost of this transformation is difficult to overstate and was rarely addressed directly in the official records. A captain who had been accustomed to commanding a boat that carried 4 forward-firing torpedo tubes and the tactical flexibility that came with them, now commanded a boat that carried nothing that could strike at an enemy. The executive officer and the torpedo officer and the helmsman and the crew in the forward torpedo room All the men whose professional identity was bound up in the act of attacking now found themselves stowing canvas bags of fuel, checking the seals on improvised transfer hoses, and memorizing the procedures for passing supplies across to a combat boat without sinking both vessels in the process. Some crews accepted this with resignation, some with bitter humor, some with a sense that they had been demoted from the warrior class to the service class, and that this demotion would follow them, if they survived, for the rest of their lives. The actual transfer procedures for improvised supply boats were slower and more dangerous than the operations that the purpose-built milk cows had developed. A dedicated Type 14 had been engineered for the process. The fuel transfer system was built into the hull, the hose connections were standardized, and the crew had trained specifically for the operation. The improvised boats had none of this. Instead, they relied on temporary pumps, on valved hoses that had to be carefully maneuvered across the narrow gap between two submarines running at a near stop on the surface, on sailors from both boats working in tandem to keep the hose aligned and prevent it from kinking or twisting. The transfer of a large quantity of fuel, say 20 or 30 tons, that might take an hour aboard a milk cow, could take 3 or even 4 hours aboard an improvised supply boat, and those hours of sitting stationary on the surface, with two large submarines lying almost motionless in the water beside each other, created a vulnerability window that was almost impossible to defend against. Every hour the transfer took was an hour in which an Allied aircraft from an escort carrier or a land-based patrol plane could be drawn toward the coordinates of the transmission that had arranged the rendezvous in the first place. The strain on the U-boat campaign's logistics network became visible almost immediately. The improvised supply boats lacked not only the specialized equipment of the milk cows, but also the carrying capacity. A Type 14 could deliver roughly 250 tons of fuel and other supplies to a cluster of combat boats. An improvised Type 9D, loaded to the maximum, might carry 130 tons, and that figure assumed that every possible inch of interior space had been filled with supplies rather than left for crew comfort or maneuverability. The mathematics of supply suddenly worked against the campaign again. If a wolf pack of 10 combat boats required a certain minimum of fuel and stores to sustain a 2-month patrol in the North Atlantic, and if each supply boat could deliver only half what a milk cow could deliver, then the campaign needed twice as many supply boats. But there were not twice as many boats available. There were fewer boats available than ever before. The older Type 9Cs and IXDs that Dönitz was converting into supply vessels were boats that might still have been capable of sinking enemy shipping if they had been allowed to remain in their combat role. By converting them, Dönitz was not so much solving the supply problem as he was spreading it across a larger portion of the fleet, like a commander who addresses a shortage of ammunition by taking away the rifles from half his soldiers. The combat crews who depended on these improvised supply boats noticed the degradation immediately. A boat expecting a transfer from what it believed would be a dedicated, specialized supply vessel would instead rendezvous with what amounted to a conventional U-boat that had been gutted and overloaded. The transfer would be slower, the reliability would be lower, the risk would be higher because the boat providing the supplies was more vulnerable, and any threat to it would abort the entire operation and force the combat boats to scatter or retreat. The relationships that had developed between combat U-boat captains and the captains of the milk cows, professional connections forged through repeated coordinated operations, could not easily be replicated with captains who were themselves bitter about being converted from combat service. There was a loss of morale that rippled through the force. The elaborate plans Dönitz had made for extending patrol ranges, for operating the wolf packs in distant waters with seemingly unlimited endurance, had always depended on the understanding that a specialized logistics apparatus would keep the hunters supplied. Now that apparatus was falling apart, and in its place were improvised measures that could not sustain the strategic vision. The human cost of the conversion policy was paid by crews who found themselves assigned to vessels that had been engineered for one purpose and then hastily repurposed for another. A sailor who had served aboard a Type 1XC before the conversion understood the boat's layout, knew where to find equipment, understood the subtle feel of the vessel as it moved through water. Now he came back aboard the same hull to find it unrecognizable. Passageways that had been crowded were now impassable because supplies were stacked floor to ceiling. Compartments that had been dedicated to specific functions were now multi-purpose storage lockers. The structural integrity of the boat, carefully calculated by the engineers who had designed it, was now being tested by the weight of fuel bladders and stores packed into every available space. The ventilation systems struggled with the new configuration. The air quality aboard the converted boats deteriorated faster than it did aboard boats that retained their original design. Men developed headaches, respiratory problems, and a persistent sense of claustrophobia that went beyond the normal discomfort of submarine service. Some of the converted boats developed sealing problems because the new cargo was stressing the watertight compartments in ways they had not been designed to endure. The speed of the improvised supply boats was another critical problem that revealed the limits of Dönitz's improvisation. A Type 14, though slower than a combat U-boat, had been designed as a submarine first, with cargo as a secondary function. It could maintain a respectable speed even when fully loaded. An improvised supply boat, grossly overloaded with cargo and without the buoyancy characteristics engineered into the Milch Cow design, was distinctly sluggish. This mattered not only for the time it took to reach a rendezvous point, though that mattered greatly, but also for the ability of the boat to maneuver if threatened. A combat U-boat could dive in a matter of seconds and reach operational depth in minutes. An improvised supply boat, loaded with cargo and squeezed for internal space, took longer to dive and could not go as deep. If an Allied escort vessel appeared near a rendezvous point, or if an aircraft was detected, the improvised supply boat was slower to respond and more vulnerable throughout the dive sequence. The combat boats being supplied by these vessels understood this, and the knowledge created an additional layer of tension to every transfer operation. By the autumn of 1943, the distinction between the elegant logistics system that had seemed possible in 1942 and the desperate patchwork that Dönitz had assembled in 1943 was stark and obvious. The dedicated Type 14 boats had represented a conceptual and technical achievement. They were submarines designed from the keel up to solve a specific problem. They were not perfect, and they had not been adequate to face the full weight of Allied anti-submarine efforts, but they had been genuine solutions to a genuine strategic problem. The converted Type 1XC and IXD boats were not solutions in this sense. They were palliatives, stopgaps, desperate measures undertaken because the proper system was being destroyed faster than it could be rebuilt. They sacrificed combat capability to achieve only a partial restoration of supply capability. The crews of these vessels knew the difference. The captains of combat boats awaiting supply knew the difference, and the strategic planners who watched the campaign's effectiveness decline month after month, patrol after patrol, understood the bitter mathematics. The U-boat fleet was eating itself in an attempt to stay alive, and the process was not purchasing time so much as it was accelerating the rate of decline. The question that hung over U-boat headquarters was not whether the campaign would continue, but how much longer it could continue before the mathematics of supply and loss made the continuation impossible. The improvisation revealed something deeper about the limits of German strategic planning under the conditions of war. Dönitz had been brilliant at imagining what submarines could theoretically accomplish, given unlimited fuel and supplies. He had been creative in designing the Type 14 boats to deliver the fuel and supplies that his theory required, but he had not fully accounted for the possibility that his supply system itself would become a priority target for an enemy that could learn, adapt, and strike back. And when that possibility became reality, his response was not to retreat or to reshape his strategic vision, but to improvise, to take the weapon systems he had and try to force them to serve purposes they had not been built for. The result was a force that was less combat capable, less supply capable, more vulnerable, and more exhausted with each passing week. The elegant machinery of the tonnage war, which had seemed in 1942 like a rational approach to strangling Britain into submission, had become in 1943 a confused scramble for survival, with no coherent strategy beyond keeping enough boats at sea to maintain the appearance of pressure against the Allies. And even that appearance was increasingly difficult to maintain. The milk cows were gone, or going. The improvisations that replaced them were failing, and the momentum of the entire U-boat campaign was turning decisively away from anything that could be called success. In the spring of 1943, the mathematics that had sustained Admiral Karl Dönnitz's vision for 5 years began to fail catastrophically. The U-boat campaign in the Atlantic, which had promised to strangle British commerce and force a negotiated peace, reached its breaking point across a single month. May of 1943 would become known in German naval records as Der Schwarze Mai, Black May, a 31-day period that shattered the operational assumptions upon which the entire tonnage war had been constructed. On the surface, the statistics were simple but devastating. The Germans lost 41 U-boats in Atlantic waters during that month, while sinking only 14 Allied merchant ships. For the first time since the campaign began, more German submarines were being destroyed than the tonnage they sank in return could possibly have been worth. The calculus that Dönitz had repeatedly presented to Berlin, the cold mathematics of attrition, had inverted. The hunter was bleeding out faster than the prey. The collapse did not arrive suddenly. The stress fractures in the system had been forming for months, but May exposed them completely. Beginning in mid-April and accelerating through the final weeks of spring, Allied hunter-killer groups, equipped with new escort carriers and increasingly accurate radio direction finding, were locating and destroying U-boats at a rate that German shipyards simply could not replace. The hunters moved with a precision that German commanders found almost incomprehensible. Convoys that should have been vulnerable were suddenly surrounded by protective screens of destroyers and corvettes. Aircraft that Dönitz's planners had not even accounted for in their calculations suddenly appeared overhead, equipped with radar that made surface attack on convoys by night as dangerous as attempted in daylight. The wolf packs could not adapt quickly enough. By the time new tactics were developed and issued down the chain of command, the Allies had already developed countermeasures. It was as though the Germans were fighting an opponent who could read their thoughts before they moved. The destruction of the Milch Cow network ran like a dark thread through this collapse. The purpose-built Type 14 submarines, which had promised to transform the operational reach and endurance of the U-boat fleet, became crucibles of vulnerability instead. Their radio transmissions, frequent, complex, and necessary to coordinate rendezvous with combat boats waiting in predetermined grid squares, had made them into beacons for Allied direction-finding equipment. Each milk cow that sent a message announcing its position and refueling schedule was broadcasting the location of multiple combat submarines simultaneously. The Allies, working from ultra-intelligence that provided them with the German naval codes, knew exactly where these rendezvous points would be established. They could calculate with extraordinary accuracy which supply boats would be there and which combat submarines would arrive to receive fuel and supplies. It was as though the Germans had handed the Allies not merely a map of their operations, but a detailed schedule of their movements. The milk cow concept, brilliant in its original vision, had become a noose around the neck of the U-boat campaign. The sinking of individual milk cows throughout May read like a grim accounting ledger. The Type 14 boat, designated as U-464, was located by an Allied escort carrier group, attacked from the air, and sunk on May 22nd. Within days, U-309 followed, destroyed by coordinated surface and air assault. U-525, the newest addition to the milk cow fleet, went down before it had completed even a single supply operation. U-492, having successfully serviced multiple combat boats throughout April and early May, was finally tracked down and sunk before the month ended. Each loss rippled outward through the U-boat fleet. Combat submarines that had arranged rendezvous with these supply boats found themselves at sea with half-empty fuel tanks and no hope of completing their assigned patrols. The carefully choreographed ballet of supply and refueling, practiced in calmer waters throughout 1942, collapsed into chaos. Boats that had traveled thousands of kilometers to reach their assigned hunting grounds were forced to abandon their patrols and limp back to French ports on fumes, their magazines still full of unused torpedoes, their hunting potential squandered. Dönitz, observing this catastrophe unfold from his headquarters in Berlin, made a decision that would have been unthinkable only months earlier. On May 24, 1943, he issued orders for the temporary withdrawal of the German U-boat fleet from the North Atlantic. The wolf packs were instructed to cease operations against the main convoy routes, abandon their positions in the middle reaches of the ocean, and reposition to quieter waters where Allied escort strength was thinner and radio direction-finding equipment less prevalent. It was not a defeat announced in those terms. German naval communications spoke of a strategic regrouping and a redeployment to sectors of greater opportunity. But every officer in the Kriegsmarine understood what had actually happened. The North Atlantic, which had been German operational territory for more than 4 years, was being surrendered to the Allies. The central front of the tonnage war had been lost. The U-boats that had sunk more than 2,000 merchant vessels and terrorized Allied shipping lanes were in retreat. They would return to the North Atlantic in later months, equipped with new technology and new tactics, but they would never recover the initiative they had held in May of 1943. The toll in human life was measured in terms that no official report fully captured. 41 U-boats lost in a single month meant more than 2,000 men dead. Some drowned in the explosions of their vessels sinking. Others died as their boats were destroyed by depth charges, ripped apart by the concussive force of explosives detonating in the water. Some were killed in crashes of German aircraft that tried and failed to provide air cover for convoys. Still others survived the sinking of their boats, bobbing in the cold Atlantic, waiting for rescue that did not come or rescue that came too late. The Milch Cow crews suffered disproportionately because they could not fight back. They surfaced to transfer fuel and supplies, exactly the moment when they were most vulnerable. They carried no torpedoes to threaten their attackers. They were shepherds without weapons, surrounded by wolves with firearms, and when the slaughter came, there was nothing they could do but die. The sea claimed them quietly, and the reports that reached Berlin were written in language that diminished the magnitude of the loss. Regrettably, the boat has not reported contact, or the rendezvous did not occur as scheduled. What made Black May truly significant was not merely the numbers, but what they meant for the future. Dönitz had constructed his entire strategic argument on a single premise: that Germany could sink merchant ships faster than the Allies could build them. The arithmetic was straightforward. If the U-boats could sink more than 600,000 tons of shipping per month, sustained year after year, the British economy would crack under the strain. Britain would sue for peace, and Germany would have won the war at sea without needing a surface fleet that could match the Royal Navy gun for gun. It was a beautiful calculation, and from 1940 to 1942, it almost worked. Shipping losses climbed towards 700,000 tons monthly. But the calculation had always been subject to a hidden assumption that German submarines could remain in operation, could hunt, could sink vessels at the rate required. The Milch Cow program had been designed to extend that operational window, to allow more boats to remain on station longer, to tighten the noose around British commerce. Instead, by May of 1943, the Milch Cows were dead, and the boats they were supposed to sustain were being destroyed in increasing numbers. The mathematics ceased to work. Suddenly, almost overnight, the U-boat losses began to exceed any reasonable calculation of what could be replaced by German industry. The Kriegsmarine had been losing submarines throughout the campaign, but the losses had been absorbed because new boats were continuously entering service, newer boats with better capabilities. A steady state was maintained between losses and construction, but in May of 1943, the balance shattered. More submarines were sunk in that month than the German shipyards would build in the next 6 months combined. The trained crews that operated the boats died faster than they could be trained. The officers who understood U-boat tactics and strategy were falling into the Atlantic in increasing numbers. The pool of experienced submariners that Dönitz could draw upon to lead new boats and train new crews was draining away. It would not recover. For the remainder of the war, the U-boat fleet would be a force in decline, piloted increasingly by inexperienced crews, operating with diminishing supplies and support, facing an enemy that grew stronger with each passing month. Dönitz's response to the catastrophe was character, stubborn, not delusional. He genuinely believed that the U-boat campaign could be revived with new technology, new tactics, new weapons. In the weeks following the withdrawal from the North Atlantic, he began drafting plans to re-equip his submarines with improved anti-aircraft armament. He authorized the development of acoustic homing torpedoes, designed to find and destroy attacking escort vessels. He began construction of new types of submarines, revolutionary designs that could fight on the surface or submerged with capability that existing boats could not match. He pushed his engineers and designers to find solutions, to create technology that could restore the U-boats to the status of a strategic weapon. But all of these initiatives were contingent on time to design, to build, to test, to deploy. And time was the one resource that Germany no longer possessed. The Allies were growing stronger with every week, not weaker. American shipyards were launching merchant vessels faster than U-boats could sink them. Allied air power was increasing daily. The integration of intelligence, technology, and tactics that the Allies had achieved was tightening, not loosening. By May of 1943, the outcome of the Battle of the Atlantic was no longer truly in doubt, even though the campaign would continue for another 2 years. The connection between the destruction of the Milch Cow fleet and the broader collapse of the tonnage war cannot be separated. These were not two distinct events, but aspects of a single catastrophic failure. The Milch Cows had been designed to solve a fundamental problem in submarine logistics, the short range of the U-boats themselves. But in solving that problem, they had created a new vulnerability: the concentration of U-boat operations at a small number of vulnerable supply points, the necessity of radio communication to coordinate refueling, the requirement that submarines operate on the surface for extended periods to complete transfers. Allied naval intelligence had studied this vulnerability with cold precision, understood exactly how to exploit it, and executed that exploitation with devastating efficiency. The U-boats could be destroyed at sea, hunted by aircraft and escort vessels. But the Milch Cows could be hunted to extinction because they could be found. Each sinking of a Type 14 submarine didn't merely remove a fuel tank from the operational equation, it removed the logistical node around which an entire cluster of combat boats had been organized. The collapse was not linear, but cascading. As the Milch Cows died, the combat boats that depended on them lost their reach, their endurance, their ability to remain on station. The wolf packs could no longer form and maintain the concentrated attacks that had made them so effective. The mathematics simply ceased to function. By the end of May, the dimensions of the defeat had become clear to every level of the German naval command. The operational estimates that had guided planning for the entire campaign, the calculations of tonnage sunk, patrol days achieved, convoy disruptions maintained, all of these had been rendered meaningless in a single month. The Type 14 submarines that had promised to revolutionize submarine warfare had instead demonstrated a fundamental vulnerability of the supply-based strategy. A modern war economy could replace sunk merchant ships. British shipyards and American shipyards could build faster than German submarines could destroy. But more importantly, the Allies had demonstrated that they could identify, locate, and eliminate the nodes in the German supply network far faster than Germany could replace them. It was a lesson that would outlast the war itself, informing every naval power's approach to submarine logistics in the decades to come. But in May of 1943, it was simply the closing chapter of a campaign that had consumed 4 years of German effort and more than 5,000 German submariners' lives, and had failed to achieve its strategic objective. The Atlantic would remain an Allied ocean for the remainder of the war. The tonnage war was over. While the grey wolves were drowning in the North Atlantic, a different kind of hunt was unfolding half a world away. As May of 1943 collapsed into June, and Dönitz's wolf packs were being systematically destroyed in the cold northern waters, German submarines were already moving toward the distant oceans where the Americans had not yet fully reached. The supply boats that survived the catastrophe in the mid-Atlantic did not all perish. Some had been at sea when their sister boats were sunk by the escort carrier groups. Others had been refitted for new tasks, stripped down further, pushed toward routes where the Allies' reach seemed thinner and their vigilance less absolute. These boats carried with them not only fuel and stores, but also a question that Dönitz could not let die. Could the tonnage war be continued elsewhere, in oceans where the arithmetic of destruction might still favor Germany? The South Atlantic and Indian Ocean represented a kind of geographic gamble. The waters off the Cape of Good Hope and beyond were still relatively thin in Allied presence. The voyage to reach them was long and consumed fuel and stores that might otherwise have been transferred to combat boats. Yet the logic was simple and desperate. If Dönitz could no longer sustain a massive wolfpack concentration in the North Atlantic, perhaps he could establish a new kind of campaign in waters where 1 or 2 well-supplied U-boats could still inflict serious damage on merchant traffic. The strategic calculus involved Japan as well. Since 1941, Germany and Japan had been formal allies, yet their war remained almost entirely separate. Japan dominated the Pacific and Indian Ocean regions. German submarines had never formed more than a scattered, episodic presence in Asian waters. Yet as the North Atlantic campaign was dying, the German naval staff began to conceive of a different kind of alliance on the water. Japanese cargo ships carried rubber, tin, and oil from the Dutch East Indies and Malaya toward home. The Japanese Navy was growing weaker by 1943, but its merchant fleet was still substantial and still valuable. Equally important to this strategic vision, the Indian Ocean and waters around the Cape presented geography that genuinely did favor the submarine hunter. The distance from Europe to the Indian Ocean was immense. The voyage around the Cape of Good Hope consumed fuel at a prodigious rate. It required supply boats. And yet, once a German U-boat reached those distant waters, it could potentially operate in relative freedom for months. The Japanese were interested in having German submarines in the Indian Ocean because they could attack Allied shipping approaching India and threaten the British naval presence there. The Germans were interested because the distance made their boats harder to find, and because they still clung to the belief that persistence in attacking merchant shipping could somehow matter. Dönitz's obsession with tonnage sinking had not diminished merely because the tonnage war in the Atlantic was lost. It had only been redirected, refocused, aimed at oceans where the Allies might be less prepared. The logistics chain required to sustain this distant campaign was extraordinary. A Milch Cow, whether a purpose-built Type 14 or an improvised Type 9D Sacrifice, would depart from a French base with fuel, torpedoes, spare parts, fresh provisions, and medical supplies crammed into every available space. The voyage to the Indian Ocean took weeks. The boat had to transit the length of the Atlantic, navigate around the Cape of Good Hope, and then move into the waters where German and Japanese submarines were supposed to cooperate. The fuel consumption on such a voyage was monumental. A Milch Cow might use up nearly half its cargo capacity simply to reach the rendezvous zones where combat boats were waiting. This was understood and accepted. The strategic vision required it. Once in position, however, the supply boat became a kind of floating depot for months. Combat U-boats operating in the Indian Ocean and South Atlantic would rendezvous with their supply vessels according to prearranged schedules. The transfer procedures, hoses rigged between submarines riding the swell, fuel and provisions passed hand over hand under the stars, were no different from those that had been perfected in the Atlantic. But the geography was different. In the Atlantic, these rendezvous happened in an ocean that was growing more hostile by the week. In the Indian Ocean, in 1943, there were still vast stretches of water where no Allied patrol aircraft had ever been seen, and no escort ships were hunting. The combat boats that operated in these distant waters were some of Germany's finest and most experienced. They were not the worn-out crews that were being ground down in the Atlantic. Many had transferred from the Atlantic campaign earlier in the war, before the attrition became catastrophic. These were boats with experienced captains, crews that understood submarine warfare at the operational level, and the ability to strike strategically against merchant shipping if given the supply chain to do so. The distances involved meant that these boats spent more time transiting than fighting, just as the wolf packs had in the Atlantic. But because the rendezvous points could be reached and maintained, the boats could stay on station longer. A Type 9D submarine with access to a Milch Cow could potentially remain in the Indian Ocean for 6 months, moving between hunting grounds and refueling points before the long voyage home. This was the original vision that Dönitz had conceived in 1941, finally able to approach realization, not in the Atlantic where it had been beaten into the ground, but in oceans where the Allies were still learning to fight. The human dimension of these distant patrols was distinct and difficult in ways that differed from the Atlantic campaign. The voyage itself was punishing. The crew of a supply boat knew they were embarking on a voyage that would keep them away from home for months. They would see no land except perhaps in brief glimpses of the African coast. The air inside a submarine packed with fuel stores became oppressive in the tropical waters of the South Atlantic. The smell of diesel fuel, fresh bread baked in the tiny galley to maintain crew morale, sweat, and confined humanity in close quarters created an environment that wore on the nerves. For the combat crews, the knowledge that they were operating in a theater where rescue was impossible if something went wrong added a psychological weight. In the Atlantic, a damaged U-boat might run for home, limping back toward the French coast, and the possibility of rescue or repair in a shipyard. In the Indian Ocean, a damaged U-boat was almost certainly lost. The distances were too great. The support infrastructure did not exist. This risk was understood but accepted by the men who volunteered for or were assigned to these patrols. They were professional submarine sailors, and this was the job they had been given. The tactical operations that these distant supply chains enabled were real, even if they were small in the context of the global war. German U-boats sank merchant ships off the Cape of Good Hope. They operated in the Indian Ocean, attacking shipping bound for India and South Africa. They worked, as much as the circumstances allowed, in something approaching coordination with Japanese submarines and warships. A single U-boat could sink significant tonnage if it was supplied and had time to hunt. A refueled boat with a full complement of torpedoes and fresh stores could spend weeks in a productive patrol area. The tonnage of shipping sunk by German submarines in these distant waters during 1943 and early 1944 was not negligible. It did not compare to the hundreds of thousands of tons being sunk in the Atlantic at the war's height, but it represented a fraction of the strategic vision that Dönitz had always maintained, the belief that merchant shipping was a commodity that could be destroyed faster than it could be replaced. As long as that destruction continued somewhere, the logic of the tonnage war theoretically persisted. Dönitz could point to the sinkings in the Indian Ocean as evidence that the campaign was not over, only transformed. But the transformation was a profound one, and the men serving in U-boat command in Paris, Berlin, and the outposts in occupied France understood it with varying degrees of clarity. The supply boats being sent to the Indian Ocean were not returning. Once they had transferred their cargo and established themselves in position, they remained in those distant oceans, perhaps indefinitely. This meant that the supply network in the Atlantic, already decimated by Allied hunter-killer groups, was receiving no replacement boats. The improvised conversions of combat submarines into supply carriers became the only source of new logistics vessels for the boats still hunting in the North and South Atlantic. The paradox became sharper and more cruel. The more the original strategy required distant operations in the Indian Ocean to continue, the less the supply infrastructure existed to support them. A Type 14 Milch Cow sent to the Indian Ocean was a Type 14 that would never return to the Atlantic, and the supply boats sent to distant oceans carried away fuel and supplies that might have sustained the dying wolf packs in the north. The strategic choice to redirect scarce resources toward distant, lower-priority theaters was driven by the logic that something had to be salvaged from the wreckage of the Atlantic campaign. The alternative was to accept that the entire tonnage war was over. Few commanders could bring themselves to that admission, especially not Dönitz, whose reputation and authority rested on the belief that the U-boat arm could still accomplish something operationally significant. The Japanese cooperation in these operations added a layer of complexity and occasional friction. The Japanese Navy had its own submarine fleet and its own logistics challenges. German and Japanese submarines operated in the same waters, but they rarely coordinated directly. The Axis alliance in the Pacific and Indian Oceans was far more nominal than operational. Japanese submarines were fighting their own war against American and British naval forces. German submarines were attacking merchant shipping. The coordination that occurred was mostly logistical. A German milk cow might refuel at a Japanese-held port. A German U-boat might receive information from Japanese sources about Allied shipping patterns. But the kind of integrated campaign that the German naval staff had sometimes envisioned, German submarines and Japanese warships operating together as a unified fleet, never materialized. The distances were too great, the communication too difficult, the operational doctrines too different. What emerged instead was a kind of accommodation. The Axis maintained a presence in the Indian Ocean and South Atlantic. The two navies tacitly agreed not to interfere with each other's operations, and a handful of German submarines operated in Japanese-controlled or Japanese-influenced zones, supplied by their own boats and occasionally by supplies acquired from captured or requisitioned vessels. The fate of the milk cows sent to distant oceans was sealed, though no one could have known it with certainty at the time. Some would be lost to Allied action. The British and American navies eventually extended their anti-submarine operations into the Indian Ocean and South Atlantic. Aircraft and escort vessels began hunting in those waters too. A milk cow operating as a visible logistics hub in the Indian Ocean was vulnerable to detection and attack, just as they had been in the Atlantic. Other supply boats simply wore out. Submarines are machines that operate in an extraordinarily hostile environment. Extended operations in tropical waters, far from any repair facility, took a toll on equipment and systems. Engines broke down, hull fittings corroded. The delicate mechanisms for opening and closing ballast tanks became unreliable. Some boats had to be scuttled by their crews in distant anchorages because they were no longer capable of the long voyage home. Others simply vanished. No wreck ever found. No distress signal ever received. In the chaos and isolation of the Indian Ocean, in 1943 and 1944, boats could disappear without certainty about what had taken them down. The logistics network that had been so carefully constructed on paper and in the design bureaus simply began to dissolve from the outside edges inward. Yet during the period when these distant operations were still functioning, they represented a kind of last echo of the original milk cow vision. The supply system that had been beaten to pieces in the Atlantic was reaching out toward new oceans, stretching toward new possibilities, trying to extend the war in places where the Allies were not yet fully dominant. This was not a strategy that could win the war. By 1943, Germany could not win the war at sea in any meaningful sense. The industrial capacity of the United States was already overwhelming the Kriegsmarine in production, and the British were adapting faster to each innovation. But strategy and survival are not always the same thing. The distant operations in the South Atlantic and Indian Ocean allowed Dönitz to report continued sinkings of merchant shipping to his superiors. They allowed the U-boat crews assigned to those boats to remain engaged in the struggle. They allowed the submarine arm to avoid the admission that the Atlantic campaign, the strategic vision that had dominated German naval thinking since 1940, was over. The milk cows that sailed toward the Indian Ocean were sailing toward the last gasp of a campaign that had already been decided against them. They were carrying fuel, food, and fresh provisions to submarines that would never go home. And they were doing so in the service of a strategy that was already becoming obsolete, even as it was being executed. The symbolic and strategic importance of these distant supply chains extended beyond their operational results. They demonstrated the reach of the German submarine construction and logistical machine at its conceptual peak. Even as the North Atlantic was being lost, German submarines were operating in waters halfway around the world, supplied by purpose-built vessels that represented years of design and construction effort. This was not the desperate improvisation of a defeated nation clinging to any tactic that might produce results. It was, or at least it aspired to be, the mature expression of a strategic vision that Dönitz had articulated in 1941. Submarines operating at extended ranges, far from home ports, supplied by dedicated logistics vessels, capable of sustaining themselves in distant oceans and continuing to inflict damage on enemy shipping. That this vision was being enacted precisely as the theory that underpinned it was being disproven in the Atlantic was the deepest irony. The milk cow concept, in its ideal form, was reaching out toward the Indian Ocean and South Atlantic, even as it was dying in the waters where it had been born. These distant patrols were simultaneously the vindication of the original strategic idea and the final evidence of its failure. They were what the tonnage war looked like when it had been stripped of the industrial and numerical advantage that might have made it work. And they were beautiful in their futility, a last grasp at an ocean that had already decided against them. By the summer of 1943, the surviving Type 14 submarines existed in a state that might be described as systematic isolation. The Allies had solved the mathematics that Dönitz had posed to his staff officers 2 years earlier. They had not merely located the milk cows, they had learned to predict them. Every radio transmission sent to coordinate a rendezvous, every attempt to communicate with a waiting combat boat, every effort to confirm a meeting point in an assigned grid square on the ocean became a beacon. The direction-finding equipment aboard the hunter-killer groups had grown so sensitive that a single transmission could be triangulated to within a few miles. The Enigma keys had fallen. The patrol patterns were known. What had once been the invisible artery of the U-boat campaign was now a marked highway, and the Allies were positioning their hunters at every junction. The Type 14 boats that remained, fewer than a handful now in active service, were no longer supply submarines in any meaningful sense. They were prey, with nowhere to hide, and an engine room full of fuel they could not transfer, because rendezvous boats would never come. The first of these final patrols began in late summer with what had once been routine. A Type 14 boat received orders from U-boat command to proceed to a designated grid square and await contact from a waiting combat boat that had radioed its fuel situation 3 days prior. The crew of the supply submarine ran through the familiar preparation, checking the condition of transfer hoses, ensuring the valve mechanisms were clear of ice and salt corrosion, confirming that the diesel bladders were pressurized and ready. There was a mechanical rhythm to these tasks, performed hundreds of times before, but something had changed in the tone of the orders. The transmissions from U-boat headquarters carried a new frequency, not urgency, but a kind of compressed anxiety, as though the men in the command bunker were sending out instructions they no longer believed would be followed. The milk cow surfaced at the appointed coordinates on a grey morning, with low visibility. The rendezvous boat was to arrive within 6 hours. The crew began their watch rotation, one man on the periscope scanning for the shadow of an incoming boat, others maintaining the engines at near-silent running, the rest maintaining the equipment that would be used to transfer fuel if the combat submarine ever appeared. The silence stretched across the hours. Radio frequencies that had previously crackled with position updates and distance calculations remained empty. The commanding officer of the Type 14 waited. On a normal patrol, this would have been expected. Boats were sometimes delayed, sometimes diverted to chase a reported convoy sighting. But the silence was wrong. There was no update from the boat that was supposed to arrive. There was no new bearing, no confirmation that course had been altered, no signal acknowledging the Milch Cow's presence in the grid square. By the 6th hour, the crew understood without being told that the rendezvous boat would not come. It had been sunk. They could have no proof of this, no radio confirmation, but they knew it as one knows the approach of a storm, not from explicit evidence but from a change in the atmosphere, a shift in the pressure of the world around them. The Type 14 received new orders by encrypted radio: proceed to a different grid square, 150 kilometers to the northwest. Wait there instead. The same rendezvous boat was reported again, supposedly intact, supposedly in need of fuel. The Milch Cow turned onto its new course. This pattern repeated across the autumn of 1943, with variations that became progressively more desperate. A Milch Cow would surface in a designated area. It would maintain radio silence whenever possible, to avoid direction-finding detection, but silence itself was a form of communication. It meant the boat was where it said it would be, waiting to be found. Hours would pass. A combat boat would sometimes appear, and the transfer would begin. The hoses passed across the narrow gap between hulls, the fuel flowing through, hands gripping the decking to steady themselves against the heave of the Atlantic swell. But more often, nothing would appear. The Milch Cow would wait through an entire watch cycle and receive new orders, redirecting it to another area, another grid square, another supposed rendezvous. The crews began to understand that they were being used differently now. They were not being sent to rendezvous points where boats actually existed. They were being sent to coordinates based on older intelligence, stale information, wishful thinking. Perhaps they were even being sent as bait, test points to see if the Allies would react, if radio direction-finding equipment would light up and reveal the position of the hunter-killer groups. Whether by intention or through the simple breakdown of coherent planning within a collapsing organization, the Type 14 boats were being sent to areas designed to fail, to places where hope had already died and no rendezvous would ever occur. One by one, during this period, the remaining Milch Cows were located and attacked. An escort carrier would launch its aircraft before dawn. The radar operators aboard the carrier had been given a grid square, precise, recent, derived from intercepted radio traffic and confirmed by direction-finding plots. The aircraft would fly out over a grey ocean and find exactly what they had been sent to find: a submarine on the surface, stationary, unable to dive because the act of diving would rupture its transfer hoses and render it useless. The first warning the crew of a Type 14 would have would be the thunder of engines and the sudden visibility of aircraft silhouetted against a pale sky. There would be no time to prepare a defense. There would be no offensive weapons to deploy. The boat would heel hard to starboard and begin a desperate emergency dive, flooding the ballast tanks while men threw off the transfer equipment and fought to close the hatches. But a submarine that has been caught surfacing by an aircraft already knows its trajectory toward the seafloor is not escape. It is merely the process of death being slightly prolonged. The depth charges would come, or the acoustic homing torpedoes, or both. The crew would hear the impact of the explosions as a series of violent thunderclaps transmitted through the hull, each one closer than could be survived. Then silence. The isolation was perhaps the cruelest element of these final patrols. A Type 14 commander who had successfully completed multiple resupply missions, a man who had shepherded combat boats through the Atlantic and helped extend the U-boat campaign by months, found himself in a situation where he could not confirm his suspicions to anyone. To report that rendezvous boats did not exist would be to invite accusations of cowardice or insubordination. To request that orders be changed or clarified might trigger investigation. The only permissible response was obedience and silence. The commander would acknowledge the new orders, plot the new course, and sail toward a grid square where he would find nothing, and from which he might not return. The crew understood too. The mechanics and engineers who had been selected for Type 14 duty, precisely because they were steady, thoughtful men, not given to panic or wild initiative, sat in their watch positions and maintained the equipment and waited. Some would have known by then that no boat was coming. Some would have heard the other boats' deaths, the distant concussion of depth charges that suggested the ocean around them was filling with the graves of their own service. The psychological weight of this knowledge, carried in silence, maintained with discipline, was its own form of catastrophe. By August of 1943, 2 Type 14 boats had been confirmed sunk by Allied action. By September, the number had grown to 4. By early October, 6 Type 14 submarines had been destroyed, more than half of the fleet that had been built. The commanders of U-boat headquarters were receiving reports of rendezvous failures, of boats that had sailed on supply missions and never returned, of silence on frequency channels that should have carried reports of successful fuel transfers. They continued to send orders for new patrol missions. They continued to issue grid square coordinates and rendezvous times. Perhaps they believed that if they maintained the fiction of a continuing supply system, it would continue to function. Perhaps they did not yet fully understand that the system had been dismantled not by gradual attrition, but by methodical annihilation. The intelligence superiority that the Allies possessed was so complete that they could afford to be almost leisurely in their hunting. Each milk cow was located. Each was tracked. The timing of the attack was chosen for maximum tactical advantage. There was no chase, no dramatic hunt. There was only the closing of a trap that had already been prepared and confirmed and weaponized. The crews of these final Type 14 submarines carried with them, whether consciously or not, a version of the same question that had animated the entire program from its inception. How long can a system survive when it is serving a cause that is already dying? They had been designed to solve a problem of logistics that had seemed manageable in 1942. By the autumn of 1943, the problem they were meant to solve no longer existed.